Ooh, the killer calculator part, Deux. This is all a ploy to schedule Code Hangout 50 for tomorrow. Let's see, I got some feedback here. By Ewan. Random thought, possibly gray out, include digit, maybe straight out. Normal font for candid, digit, and bold font. All right, so we can do that. So we can do text decoration strike through, I think. I'm not sure if that's how it works. Apparently not. You know what I'm gonna do? If I put this on this side, then I can do this and this. And we can look at this style. Not used to this layout. Alright, digit exclude. Text decoration. Line through. We can try it. Not too fun how it looks. And grayed out. So instead of this, we might want to do it partially transparent, maybe? Nope. So if we make it semi-transparent, that will make it that will gray it out naturally. Alright, let's try that. So grayed out, exclude digit, make strike them out, normal font for candidate digit, and bold font for must be included. So include is font, wait, 600, let's say. And yeah, this is a bit too. Exclude 9 A B. The strike through is a little. Is there a way of doing a diagonal strike through? CSS strike through diagonal. Is there a way of forcing a different strike through? Can we do this, perhaps, with a pseudo element? So if I do this, after display inline block content space, maybe 2 spaces, or let's do this for a sec here. So if I do this, okay, content. So if I go change this after element to position absolute. So then it comes here. So if we do it before, and then position absolute, I think then the problem is it won't be on top. But is it on top or is it not on top? Well, if we do this here. Wait, if we do 2 spaces, or let's do 2 O's, and then text align center. Maybe that's better. Text align center. How do we center it as a absolutely positioned element? Vertical align? No. Horizontal align self center. Align self, no. Align items. Align center. No. Left auto. Right auto. How do we center align something on top? What if we make this inline instead of inline block? Text align center. What if we do text align center here? Text align center. Horizontal align. What other alignments? Align content center. Sure. What if we do margin left minus 50%? Yeah, the problem is position relative. No, absolute. And then we'll do this one, position relative. Ah, okay, so that works. So if we do digit exclude, position relative, position absolute, text line center, and margin left minus 50%. So now the margin is taken relative to the relative parent, basically. And that should work. Let me just check. Okay. YouTube stream seems to be running. Our Twitch stream seems to be running. Everything looks okie dokie. All right, so strike this through. Okay. And now, if we just transform it, and maybe we can get away without doing a prefix. 344 degrees. Why would I do that 344 degrees instead of just like 15 degrees? All right. And instead of that, we'll make it a space. Oh. Uh-oh. Line through on a space. It doesn't seem to like that. It doesn't like styling a blank space. Oh. Is it the margin? Background hash C003 9. Let's see, if we put 3 spaces in here, we get nothing. Okay, what if we put non-breaking spaces in here? Okay, CSS content spaces. Display block. Can I make it a block and still have it work the same way? I mean, at this point, we don't necessarily need to use a strike through. So CSS strike through diagonal pseudo before space. Because we could literally just put a line, like use a border. Or even a background color with an empty content. So what if we do that? Border bottom 1px solid. And we'll do the same as the text color. So if we do that, 1px solid, we don't even need that. Probably don't need that either. And then we'll do width 100% and height 50%. Okay. Height. So what about outline 2px solid magenta? Just to know where that box actually is. So if this box wasn't rotated, Control-Shift-C. If this box wasn't rotated, it would be sitting there. So I think one of the issues is that it's inside the border. Border color. So we have a border on this thing, right? Border. And we have padding. So it's listening to the padding. That's a bit of an issue. But we could do margin left minus 0.1 rem, for example, whatever the padding is. What is the padding? 0.2 on both sides, so that should do the trick. And this could be 35 degrees, for example. 35, so 310. No, 360 minus 35 is 325. Now the problem here is the rotation happens from the top pivot. So if instead of height 50, we have height is 1, and then we'll do margin top is 50%, and then height is 1 pixel, and then the border is actually a border top, and then the diagonal line still looks a bit odd. Where's this box now? This is so tiny. So can I make the height 0? I think the border is still on the outside of the, but that's actually pretty good. So if instead of a border, we would say background -FFFB, and then height 1 pixel. Yeah, I think that's pretty good actually. And we could do width is, let's say 120. And then margin left. What if we do, the problem is we're mixing percentages and margins, right? What if we do padding minus 0 minus 0.2 rem? We can't do negative paddings. Margin left. Without the margin, it's over to there. If it's not rotated, it should be perfect. Yeah, that looks pretty perfect. But then when we rotate it, I mean, it's still correct. What if I wanted to make it wider than this? Problem is now hey Mark, how are you doing? Oh, sorry. I forget that my stream cuts off the bottom. Is there an easy way of doing this? How's that? Oh yeah, because of my head. Yeah, this is not the ideal layout. How is that? So I'm looking at Ewan's recommendation in the web app feedback channel from yesterday or this morning. And I actually like them to kind of create a more neutral, like the red and green was just a quick placeholder, but to create a more neutral, more default styling for include and exclude. I could modify this by saying calc minus 20% plus minus 0.2 rem. Yeah, and that would align it. So this would give us the 160% wide and the minus 0.2 of the REM. And then if I rotate it, so it's a bit messy, but I think I'll allow it. So if we do width, let's say 140, and then this will be calc minus 50% minus, so this would be, so margin left would be negative 0.2 rem. Whoops. Minus, and now it won't be minus 50. It will be, so wait, a bunch of stuff changed actually. So width would be 140. So this is minus 20%. And then instead of border bottom, this is background. Will be just that. No text decoration. No text align. So we have a 1 pixel height now. Here. We have this margin. And then the rotation should be 115 degrees maybe, or 100, it should be 125, I guess. And the outline we can hide for now. And this should be just minus 20%. And I think in calc we should be fine to mix styles like that. Oh, nope. I forgot top should be 50%, I believe. Yeah, I think that's all right. And the height might, I don't know if we want to bold, quote unquote, bold it. All right, it's almost a little too wide now. So how about we make that 100, like just 10% on either side. Still looks a bit weird. Like it's almost like the letter is too high. Is this just me? Like, there's more space underneath the letter than above the letter, even in this. And then the line is like slightly low. It's probably because the line starts underneath the top. So the top is halfway down the character, then the line is too high. And the line should really be, you know, so this should really be calc 50% minus 1 pixel, half the height of the line. And if we make the line rem based, so let's say 0.05 rem, and then this is minus 0.025 rem. Would that work? That's actually thinner. But 0.1 rem seems too much. But it looks slightly more centered now. Ah, that's not bad. Maybe we don't need the 2 pixel, the 10% buffer of the strikeout after all. Maybe this should just be 100% width and rotate it. Maybe that's enough. What do you think? And is that the right angle, or should it go top to bottom? Or bottom to top? Maybe bottom to top? It is bottom to top, all right. Sorry, it's a bit hard to see all the way on the right edge of my monitor. It's a bit of an odd angle for me. What do you think? Maybe we can get rid of the red now. That's the real question. What if we get rid of the background color? And here's my nose itching starting. Something about streaming that makes my nose itch. I think we need to do something to the background if we want to make the character white. Or maybe we don't want to make it white. Maybe we want to make it black but transparent, so it's grayer. So the normal digit color is... we should probably specify the normal digit color as black. So what if we make it black but less opaque, which would automatically gray it? Yeah, that's not enough. 9? No. 6? Ah, wait, what am I doing? 9, 6. Ah, wait, yeah, this color needs to be the same. Okay. Actually, is there Unicode for a vertical line? Ah, because we've changed the height and all that stuff, so that's not really applicable anymore. Problem is, when you're just fading things with transparency, I feel like you're kind of harming readability, especially on relatively small sizes. And of course, the outline here almost makes it more visible. So what if we do this? I don't like that the strike-through makes it... I don't know, it almost obscures it a little. What if the strike-through was thin after all? What if it was like this? Yeah, that's maybe better. And font weight. Font weight 300. I don't know if that represents well. Yeah, that's the next step. So there's two choices, right? Originally, I was thinking, because right now, it actually, you see, it only shows 4 out of 6 combinations. So we could remove them, but then, of course, our UI disappears. And Ranks made a suggestion for basically showing the digits as a separate UI. But I'm not sure if that UI would then be self-explanatory. While this UI, like 99% of people, I think, just use this, because that's basically what the Studio Goya app gives you, you know, and power users want more. And power users, they'll, you know, and there's two things I think the other tool that people showed me does. That you can select on rows and mark the whole row and then select digits. Now, right now, the cursor is just a pointer for the whole thing. But what I'm thinking is, if the cursor isn't what it is right now, then you will notice when you're hovering over the digits, and it kind of will teach you what to do. And then maybe the rows will have their own little markers. And I already have the code for actually calculating the right thing. So I just wanted to implement this little suggestion regarding... So what did he say? So we have bold for in. So maybe we don't need the green for the in color either. So for include, maybe instead of having a green background, we'll just darken it a little, just to highlight the digits a bit. What do you think? In, out, neutral. In, out, neutral. In, out, neutral. The out digit is not gray enough, I think. Also, the problem is because I'm having a transparent line on top of the transparent character. Where the line and the character cross, you get little black dots. Hey, Shelby Lee. And I'm not sure if there's an easy way I can stop that. 1 second, let me... Because I can't zoom in anymore because my resizing will fix that. You see how, where the diagonal line and the digit cross, we actually have these black, dark areas. And I'm not certain there is a way to stop that. And can I... My god, this thing is laggy as hell. Is there not a way of disabling the magnifier?
Play forward.
Oh, no. Why does it do audio? Is there a way of stopping this? Microsoft George. Oh. Oh, no.
Play /pause.
Does that... Wait a second. I gotta try this, sorry. Control Alt.
Blank. Sum 25 4/6 combinations.
Okay, that's actually kind of cool. Yeah, I'm starting to think the same thing. I'd like to just keep it super subtle because I'm already like layering so many shades. So maybe the gray, the green is a little too bold. Do you think for the strike out we should also stick with red then? In a similar fashion? Or is it too subtle? Because the problem is the darker red actually makes it stand out more rather than... Although actually maybe having it stand out is not the worst thing in the world. Maybe I'll just go with this for a bit. I mean, the strike out and the bolding is maybe not that self-explanatory. Because to be honest, I'm trying to avoid having to do a bunch of stuff for the color themes. So, and because I don't have color thematic APIs built in yet, so I don't have one place to change colors right now. Each theme re-specifies a whole bunch of colors. All right, I think we should. Let's look at functionality first. All right. So how do we want to gray out the lines? And I think I'm going to go back into the other layout. Can I make this bigger? No, it won't actually get bigger. All right. Oh. So let's start with doing something to each row. So this thing seems to correctly identify stuff. Let's see, including 4. Wait, so it says false, 4 rows that should be included. Okay. Wait, no. So for neutral digits, it should exclude them. If I do this, it should now return a different value for the rows that don't have the 1 included. Right. So let's output the 2 aspects separately, and then the combined one. So let's see. Include 3. I'm gonna make this bigger. So, when we're including 3, we now get trues on the 3s. The thing is, we don't want to exclude the... Yeah. So that's a question I can't figure right out. If you have both, because ranks implied we have 3. Don't knows includes exclude, right? So we can all agree that if you haven't specified anything, they should all be included. But I feel the moment you're specifying a 3, you're basically implicitly excluding the ones that don't have the include, right? So the don't knows only apply if there's no includes and excludes. Similarly, if I exclude the 3, yeah, so the include is basically a reverse exclude, right? So the include basically means exclude everything else. So then the question becomes for the neutrals, right? So neutrally, these are all true for the includes. Now if I press 1, these become false. Yeah, okay. So wherever this is true, we want to include. So right now we want to include all. If I click on a 3, we only want to include these. Now if I exclude the 3, we want to include these, but not these. Even though these are true by the include. So the excludes, all right, let me just double check. So the excludes are always false, and then they become true. Yeah, so the excludes currently are wrong for the neutral position. So the exclude term currently is not entirely useful, unlike the include term. So if we are doing the reverse here, so if we're excluding 4s, what do we get now? Wait, first of all, for neutral, the third term is false. And then for excludes, the third term is false. It becomes true for the excluded. So we basically want the reverse of that. Right? So right now, I'm looking at the third column here. They're all true. And now there should only be true for the ones that are not excluded. So if I exclude something from every row, yeah, only the last one is true. And if I exclude 2s, all of them are false. Okay. Now for the includes, which is the first term, it's all true. It's still true for the included ones. But now it became false, even though we have an included one on the 3. Wait a second. Okay, that's a problem. So I'm looking at the first column here, though that's the include term. So they're true when nothing is selected. If I have some selected, it's true for those. But if I have 2 things selected, okay, so it's an include all, which is not what we need. No, it is what we need. Yeah, okay. Sorry, my bad. Yeah. Okay, so there's 3 trues now. Now, what if they're not overlapping? So if we have these 3s, let's say, and these 5s, I guess the 5 here should be false, which is the third from the bottom, which is here. So only the 3 and the 5 will be true. Okay, so if we're ANDing these 2 together, that should give us our filter. Right, so the last column now is what we care about. So include all the 1s, so the third column is true, but exclude all the 5s. So now only the first one is true and these 2 are true. Exclude all the 7s. So now only the first and the fourth is true. If we exclude 8s, only the first one will be true. Okay, so I think this is our include-exclude factor. Okay. So let's do a little helper function here. Const is inc. And what we do, we pass in a combination. Comb. And it does this. Right. We don't even need that set of brackets. And then is excluded. And we're using this term. All right. And now we can just do is inc combination, is x combination, and then the 2 ANDed together. And that should be it. Let's just double check. Include all the ones. Exclude all the twos. So it should only be these three. Exclude all the sevens, then it should be those two. Exclude all the fours. Now that should false all of them, but now if we say include fours, it should be only these two. And let's say include threes. Now this should still be excluded, so only this one is true and this one won't be true. Okay. And if we make ones optional, it should be only this one. Now the question is this one here. Yeah, because it doesn't have the included one. All right. And if we didn't have an include, these two would be in because it will only look the excludes. All right. That looks good. Okay. So now the thing is right now, I'm only looking at the valid combinations. In other words, it's already taking into consideration the given digits. So instead of doing that, I think we're going to handle the given digits as excludes. So in other words, if I go here, sorry, as includes, it will just pre-include the 8, but still show all 6 combinations. One issue we still have is if we have too many combinations. I made it fairly slim, but especially in the mobile layout, it's quite possible for it to overload on combinations, especially on a very large cage. I don't know what the biggest number of combinations we have in this puzzle. 4 out of 6, 8 out of 8, 8 out of 8. I don't know what the maximum combinations is. We could actually calculate that, right? All right, but let's first implement it and then we get, I don't know if we have to implement scrolling for mobile. It might not be the worst thing in the world. Okay, now this thing, get combinations, is already calculating the ins and outs according to our thingamajig here, right? So what if we don't actually do that, right? So what if we do let all comps, and then we'll just output that for a sec here. Oh, my nose is so tickling. Why is it tickling when I start streaming? Apologies. Oh, that's just terrible. Okay, so now if I select this cage, 4 out of 6, it's showing 4, but all comps should be 1, 2, 3, 4, 5. Yeah, all of them, right? And then summary should actually update. So what we should do is we're looking at cage digits. So to be honest, let's just because what I'm doing here should really be happening up here. No, let's do it here for a sec, and then we can bring it back into the fold, so to speak. So we're passing in get killer combinations, and then here get combinations cage. So cage.cells, cells prop get digit yada 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 parse in digit. So cage digits, cage digits, cage digits. Cage digits 8. And if I put a 9 here, no, a 9, no, 9. Cage digits 8 and 9. Okay, so cage digits should be an array actually. Let's make sure it's in the right format. Yeah, 9, 8. So if we join cage digits into our includes, right? So where are we doing our includes calculations here? So that goes here. And the include exclude function can go up to the top here. Is combination included, is combination excluded. Okay. Excuse me again. So the question is, do I want to permanently add that to our included digits? Probably not, because I still don't know what to do with the included digits when you're switching cages. Should I wipe it? Should I remember it per cage? That's something else to remember, because I don't want this to work like an external calculator where you have to put in all the work. You know, this should be as automatic as possible, but it probably should remember things per cage. So that's going to be a little tricky down the line. So for now, what we're gonna do, I mean, I could temporarily add them and then remove them again. Or I could pass them in. So if I do this complete digits. If we do this. Because in theory, you could filter by these, right? I pass these in like that. Then these functions become independent. Don't know why there's an M there. Right, now these are pure functions we like. And then here we go, const filter comb equals inc digits exc digits, and then comb, and then basically this. And that's our filter function. So we can do comp, and then we can do comp.filter filter comp inc digits exc digits. Right? That should get us two lists. Or just, you know, blow up. Did I? Filter 77 77 what are we doing here? Comps.valid. No, we're going to do all comps.filter. All comps.filter. Right. And that will currently not take our digit selection into consideration. All comps filter. So this function should get a comb in there, not comp. Comb for combination. Why show the combination when not possible to given digits? Well, because first of all, it doesn't help that the filtered list is short, because we still need to be able to show the long list before it's filtered. So, you know, we got to make it work anyways. So that once we can filter the long list, right? Secondly, if you want to unfilter certain options, remember, we don't necessarily have all the information on the board due to other constraints that our system doesn't understand, lines, etc., things like that, right? So another feature we will have is to manually mark the list. So on the app, you can click on a row and just mark it. It just gets darker. That's it, right? So we got to do it that anyways. And thirdly, if you exclude a digit and then you make that row disappear, suddenly you can't include that digit again. Then we need additional UI. So we actually need more space then, right? So we're making it less compact that way and more complex because I have to implement additional UI. So I'm trying to remove the necessity for additional UIs, right? So we got 6 here now. Is that correct though? 6. Cage digits. Because it's not it's not considering the cage digits yet. All right. So what we can do is ink digits and then cage digits. Right? And I don't know if digit duplication in this case is as a problem. So now we end up with 3 that include 9 and 8. And if I change this to a 7, we'll end up with 3 that include 9 and 7. And if I have 9, 7, and 8, we'll end up with 3 with 1 that has 9, 7, and 8 in it. So that does that part. And now we can just visualize it. All right, so that valid comms equals, right? All right. And then we might as well output these as well. Excluded digits. All right. And then instead of doing all of this, we're going to use valid comms here. And then all comms here. Don't use this anymore. Rep. Now this won't. The question is, do we mark the 8 as green and let people to include exclude digits that are actually in the board? And how would the merging work? Would I, if somebody excludes a digit that's actually in the cell, we'll see how that interacts actually. Why not? So comms valid. So valid comms. So for now, this would only show the valid combinations, and you'll see the problem in a second here. So if I go here, so it shows 3 combinations, but now I cannot. So let's say if I include the 5, you see, now if I exclude the 5 is gone. I can't include it now. Right. So that's not really what we want to do. So all comms. We go back to all comms, right? So when I click this, why do I have to click twice? On other cells, I only have to click once. Why? One second. It's capturing a click somewhere, and then it's stopping it from actually doing its job. So this comes from dispatch event handle act. Now handle act, I presume, is blocking passing through the event, which it shouldn't. Except it isn't. It isn't. Is it maybe calling something else it shouldn't? No. Going here, handle act. Update, and it's not even looking at the event here. Why is that blocking the action from going through? One second. What else is going on here? Handle selection document, attach toggle display, update. Why is that doing a deselect? So the last action was undefined, undefined. There's something wrong. There's a bad action in here. Yeah. So if I click, yeah. I don't know how that action, the undefined, undefined action got in there. I have to be careful. See if that's a bug in the system or something that just happened while the code was in an incorrect state. Okay. So now it's showing all of them, and now I can mark them up accordingly. The only thing is, okay, so the included digits aren't sort of merged. So let's see what happens. Inc digits here. So we kind of, if we do this for now, and there's no excluded digits, so if we do this, go here, open this up. Ah, this is not doing what I hoped it would do. Let's try this. Click. Inc digits, X digits, Inc X. And it should mark these digits as included. Inc digits, K digits, includes digits, include. Wrap digit. Wrap digit here, unless there's some other circumstance. Nope, these are not getting wrapped correctly. Okay. Let's find out why that is. And then wait a second. I don't know if these digits are they look like they're numbers. Oh geez. The problem is if I normalize to numbers or strings or whatever, yeah, I don't want to deal with all of that hassle. I think we want to normalize to strings then. So these shouldn't get mapped to parse int. These should be mapped to string. And they shouldn't be digit, they should be value or val. Because ultimately we're gonna want to work these for letters as well somehow. I don't actually know how that's gonna look, but I don't want the code to just blow up on letters, basically. All right, so 8 and 9 are included, but it's not showing us. Yes, so it says 3 out of 6, but it's not marking them yet. Okay. Now if I exclude 7s, it says 2 out of 6, which is these two. Okay, so the summary is correct now, which is great. Now we have a isCompInc. I'm almost tempted to do a isDigitInc as well. I'm just thinking here. Because what we can do here as well is if we do function carrying, right? We're filtering combination here, but we also want to filter digit. Yeah, those are actually two very different things, right? We can't really combine them. So if I do const is digit inc digits equal or is val inc vals val, and it's basically going to be this. Inc vals includes, nope, inc val includes string val is val is, I'm trying to come up with a name. I just want to do this so then I can create functions for includes and excludes, and I don't have to do the whole currying thing later down the line manually. Is value included? Is val contains val. Contains val. If I do this, right? Vals val. Also, it includes string val. So contains val. Okay. Now, if we do this like that, like that, and we're going to rename to vals as well. Inc vals, x vals, inc vals, and x vals. All right, so these two are generic. This contains val. All right. I'm going to rename this to inc vals, x vals. And what it's going to do is actually it's going to create two versions of these. Const is inc vals. Wait, is inc equals is comp inc vals. Right, and then we'll do the same thing for is excluded with the excluded vals. Right, now we're going to return a function that takes a combination and is going to call this and that is inc comb and is excluded is excomb. Right, and now we can, after we've created the cage digits, and we don't need all combinations at all here, after we've found our cage digits, excuse me, we're going to create these relevant functions here. So we're going to create this, and we're going to use this as our, and we're going to do a little separate const inc vals equals inc digits in cage digits. All right, it's going to be inc vals, and that's excluded digits, and we might rename those later. Is inc is exc, and then const filter comp inc filter comp by vals. So we're just gonna do filter comp equals filter comp by vals, inc vals, and x digits. All right, so then we have our combinations. Then this we're just gonna pass in filter comp We don't have to do anything twice. And then here we can just use isInc digit, and we're gonna rename this to val. Right. And then we're gonna do the same thing with exclude with isExcluded. I'm just refactoring it so things look a little saner down the line, and then we can just do these things. I mean, we could. It wouldn't be shorter if we do and or and all that stuff. We could also even do kind of lookup tables, inc, exc, and all that stuff. All right. I mean, even if we make these shorter. All right, I think that. I think that's it, right? Nope. Comp.excluded. Is that a P? Did I use a P somewhere? My dyslexia is kicking in hard with the B and the P. Between combinations and, I don't know, compilation? Compiler? 48 or 64. Comb. Comp.includes is not a function. Comp.includes is not a function. 64. 60. There's a 65. Where's line 64? Oh. Killer cages. Wait a second, what's going on here? What's going on? Comp that includes not a function. Array.find d comp is 48. 48, 53, 94. I think the first one is the line, right? 94 is inc is x. Is inc is x. All right. After we've set all these up, let's just log them out first of all, so we know what's going on. Inc vals is inc is x and filter comp. Just make sure these are functions like they're supposed to be. So included digits, nothing. Excluded digits, nothing. Cage digits, 8, 9. Included, excluded. Wait, no. Is excluded. Takes it in a combination. Oh, a friend has just shown up in Malta, apparently. From the UK. Included is 8, 9. Is excluded. Comp, yada, yada, yada. So all I can imagine is one of the... Oh, wait. Is excluded shouldn't get a... Shouldn't... Is inc... Is... Oh, wait. Not is combination included. Ah, contains value. Okay, that's my mistake. These are for... Yeah, I'm gonna call them isval inc isval exc, just to avoid exactly this issue where I confused the functions operating on combinations versus the functions operating on values themselves. All right, here we go. So if I click this now, I get it. Deselect. Okay, what was previously selected? Select something new. Do all of this stuff, and now we should have 3 valid combinations, all the digits marked correctly. If I change that from a 9 to a 7, it does this. Now if I exclude a 7, and I put a 7 in here, it doesn't overwrite that. So which are the valid Yeah, so there would be no valid combinations if I'm both including a 7 and excluding a 7. So these will not override what's actually in the cell, which may or may not be what we want. Oh, that's really noisy. Because people might want to specifically override what the cell currently shows. They might want to run what-if scenarios, for example. So that's definitely something I have to consider. We might have to change that. All right. Let's get rid of all this spam and move to actually marking the rows accordingly. Right. So that's our digits being... yeah, no, okay. Yeah, so this was where I was marking the line. So, we're probably gonna have either just one marking, the line is not valid, or two markings. We are manually excluding the line, although, yeah, or we're manually marking the line versus, you know, the line's already been marked. Let's just try something with I'm just thinking, do I really need this in the end? Probably not. But we're just gonna do something like this. Valid comps dot includes comb. If yes, we'll just add class. Actually, if yes, we do nothing. If no, we do class equals invalid. And I think that's it. All right. And then we can probably do that if we wanted to. Or we can actually maybe do something like this. And something like this. Don't even need that. Go here, click that. And now if we look at these elements, these LIs, they have a false there. Includes comb. Don't know how I ended up doing that. All right, so now we should have these include. Invalid. Okay. So now we can do these here. Dot invalid. And now we have to decide how we're gonna style these up. So first of all, we can just do something like text decoration, strike. No, line through. Some odd wording. Oh, that's interesting. It only applies it to things that aren't inside the spans, which is so weird. Why would it do that? Okay. So I think the easiest would be just to do something like opacity 0.6. That's fading it, right? But of course, we know that that has a problem with readability. Yeah. And especially the marked digits are kind of too powerful here still. And the other thing is we have all this other styling. So if we want to override that, so for example, if we want to do text font weight 200, we have to mark it with important. Otherwise, we're going to have a bit of a mess of styling there. So you see it doesn't actually override the font weight on these. So here's font weight 6. So this is invalid on the LI. But somehow I don't see the, oh, here we go. Because it's less specific as well. So we have to work with specific, and the important doesn't override it. Ah, man. The specificity is a problem. So, because we have two layers, we have the per digit styling, and we have the I'm just thinking maybe we can do the other way around. Maybe we can have an include and exclude styling on the rows, and then make sure that this only works for that. What I mean is that we actually pre-specify this. This is only on the valid rows, right? Although we still want to mark, because your excluded digits will always be an invalid row. So if I go here, let's go here. No, let's go here. Let's go here. So the excluded digits will always be on an invalid row. So there's no point having that styling not be visible on an invalid row, right? Also, I don't see any change in styling right now. Ah, okay. It's just not visible. All right, let's think about this. Invalid rows. I feel like if I make the background darker, it would actually make them stand out more. So, geez, no, wrong app. So the question is, I'm going to look at the SudokuPad app again. So if I mark it, it does make it darker, but it actually makes it a color. And then it makes the text faint, as if the background is over the text. The problem is I'm already messing with transparency so much down here that it'll be hard to, like, it'll be too many layered styles, if you know what I mean. I mean, for now, the easiest thing is obviously to do background, which is currently this, and then change it to something darker. 9999, something like that for now. Just to visualize the differences. Oh, what's going on here? Why can I not change that marking? So if I'm here, right, I'm clicking the 7. Oh, it keeps adding them. Yeah, that's. First of all, why? It shouldn't be doing that, right? It shouldn't be doing that. Because, the classless includes that already. So let's output that first, so we know where we are. Then we're gonna output that. Do we have include, exclude? So if I go here, go here, exclude this 6, go here. How was it possible before? Was it because... Wait a second. So if I exclude 7 here, and then go here where the 7 is included... Yeah, now it adds the 7 multiple times. Okay. The include green just should be black and purpose bold, not white. Currently it reads as excluded because it's very bright. What? The included digit, green digit, should be black and purpose bold, not white. Does it read as excluded because it's light? I thought it would stand out more. I thought the white would be like, hey, the light is on, it's activated, Like, because the neutral color is quite subdued, right? So you think making it light makes it excluded, huh? I'm also going kind of by the mobile app where they're white by default. I mean, we could try that as well. I mean, here, obviously, they don't mark individual digits. Maybe they should be white by default. The included green digit should be black and perhaps bold, not white. It is, first of all, it is already bold. And I don't agree with black being more highlighted than white. Isn't white a highlight color? What if they're white by default? Let's have a look at that quickly. So what if they're white by default? Full-on bright white. And then when they're included, we make them black. What does that look like? Ugh. Yeah, the problem is I'm getting to a point now where I'm overlaying multiple styles, so I feel like I actually have to figure this out a little bit. I mean, if I could limit it to the background, but right now, the problem is the design is a bit confused because right now it hasn't decided what's highlight. It hasn't decided if dark is highlight or light is highlight. I mean, I could make a color highlight, but I'd like to avoid that as much as possible. That's why the green and red wasn't super... I wasn't super happy about that, and I was hoping to be able to handle it with Strikethrough. Because you get so many layers now, colors, fonts, textures, and all that stuff. One thing I wanted to try quickly is, what is the largest number of the longest list we can possibly get? Let's see. So we can find killer calculator here, and then get killer combinations, right? That should execute, right? So if we do new air. By the way, I haven't been looking at Twitch chat. And in fact, it's lucky I wasn't looking at Restream chat because it doesn't seem to be working at all. Why the hell is it not working? Okay, nothing in Restream chat. I don't know if that even goes through, but it's not seeing the okay, it goes that way. All right, that's odd. Array. So we want sums up to 45, right? For each sum, and then sizes up to 9. I don't even know how many freaking that's a lot of combinations, isn't it? I mean, it's more than we need. Let me try something quickly here before I freeze up my computer like an idiot. Let count equals 0. Count plus. How many combinations are there in total? If I do a dumb version without, you know, without figuring out that, you know, obviously not every size and every combination. Oh, 4 and 5. Okay, that's not a big deal. Is it though? Is it? So we should be able to now do let count comes equals, and then comes dot push calculator, get combinations, and I think it's sum. Is it size or which one is it first? Size sum. So size sum push, and I think we need one more. And then we can output them. 405, we can just manually look at them quickly. All right. Most of them are 0. All of them are 0? Wait, what's going on here? All of them are 0. Get killer combinations. Size, sum. Sizes. Plus 1. Sum plus 1. Wait, what am I getting wrong here? Let's do all sizes 2 only. And here we're gonna actually do log size plus 1 sum plus 1 killer combinations. What am I getting wrong here? NaN, what? Size, sum. Oh, I'm an idiot. Size in the second element. All right. Let's do that. Okay. Still, most of them will be 0 because obviously. So, for example, for size 1, sum 1, we have an option. For size 2, let's do this. Let's put in these 2 as well. Like that. Four and 5, right? Yeah. Shouldn't be a problem. So 1, 1, 1, 1, 1, 2. So for, and the first one is the size, right? So for size 1, sum 2, yeah. So for all the size 1s, we should have 1 sum each. 1 size 2. But it's looping through the sizes second. And then sums, okay, all the way to 45. And then we have 1 with, yeah. And we have, let's say, all right. So basically, we're looking for the longest of these. So we're gonna do sort 8 B, and it'll be a 0, 1, 2 dot length minus b 2 dot length. That should sort them by the length of the combinations. So these are all the zeros, and then in the end, the longest one we have is 12. And that's a 5 cage with a sum of 25. So 12 combinations. So here we have an example of 7. I think 8 is the longest we have here. 12, here, 8. So 4 more than this, 1.5 of this. So it just almost doesn't quite fit. I mean, the idea was for me that you could have it open while you're typing in things, but obviously you can't use the keypad at the same time. So that can be a little bit annoying. While if we put the buttons in here somehow, you can have the keypad open at the same time. So it's a little bit of a, all right. So 12. Okay, we know it's 12. That's something to keep in mind. All right, so we're going back to, sorry, I'll get sidetracked there for a second. Going back to the styling, I'm still wondering if I can get rid of the, first of all, white text on dark background, black text on white background. Secondly, do I want to make it bigger and then deal with larger lists separately? And thirdly, how do we overlap the styling of the rows and columns? Like, we don't necessarily need to style the whole thing. We could have a symbol there, right? So the calculator that oh no, don't tell me I closed it. So there was a calculator that Ranks sent me the link to yesterday. Let me find that quickly. as a sort of template of what they use. Is this a unique sum helpers? I believe it's this one. Yeah. So let's say size. What did we just say? Size 5, sum 25. I think that was the largest. No. No, clearly not. 525. 525. Let's just put that over here. 5 size. Oh, size 525. All right. And if I remove this one, it marks it. And if I say exclude 3. So the excludes, it just takes it out of the list because it has a separate UI for them. And then the markings are remembered separately. So the idea is you can make a list and then you can tick off the list. All right. I think one thing before I do all of that is I'm going to have to change how I store the data so I can store it per cage. Because right now there's a huge mess between checking things and then like it remembers the 7s and all that stuff. Now, I don't know how these calculators deal with that because they have no conception of the cage, right? So I guess they expect you to just open additional calculators. And I don't think the results from one cage are ever carry over to another cage, really, because each cage has its own kind of circumstance, right? The other thing I'm just thinking now is, what if we have some small UI near the cage, right? What if each cage has a little triangle button when you hover over the number or something? When you tap it, it brings up, or just as you hover over the cage or you select the cage, it just gives you a little transparent floaty display for that cage. I mean, in a way, you can already do it by having it popped open like that and just going through the cages, you know? Yeah. All right. Let's move the included, excluded filter stuff to a per cage thing. So, when I'm selecting a cage, so update happens from handle click. No, handle click is just toggle display. Yeah, forget that. That's not important. Toggle display. Classless toggle. Yeah, no. Handle click details. Nope. Handle act. This update. Okay. So this update, step 1, find all the cages, matched cages, no cage selected, okay. Let cage equals matched cage, okay. So the question is, first of all, is there an easy way of giving a cage a unique identifier? Oh, and handle act, we're gonna silence that noisy bastard, noisy logger. So if I click on that, we get a cage. And all cages come from killer cages, current puzzle cages. So let cages, let all cages equals. Okay. Matched cages. So first of all, let's see if we can put these all into something else. So we can do something like p.get cages. And it basically does these 3 things. So all cages, cage, so this transforms to all killer cages, and then matches to selected cells. Right, so this is a neutral operation, and then we just return. And then we just return. We'll do all is all cages. Killer equals killer cages. And matched equals matched cages. Or let's see. Wait a second. So killer cage, all cages filtered, yep, map, yada yada. So all cages is always an array. Killer cages will always be an array, and matched cages, and we'll call it selected, and we'll do it matched cages or array element 0. So if there's no matched cages, it should come back as an undefined. Right. So then here we can do this, get cages, this dot get cages. I'm just cleaning up the API a bit so I can start thinking with my brain again. So get cages, all is 40, 13 killer cages, and 1 selected cage. And if I do this, we have all, and then selected, there's 1. Yeah, no. What we want to do is if matched cages, so matched cages is always an array. So if matched cages, matched cages dot length equals 1, then matched cages 0, else undefined. Right. So if I do this, selected should be so that still gives us this cage as a selection, but this will not give us a selected cage. Or it still does? No, it doesn't. But this still does, which is fine. Okay, all right. And I guess we can just do that. All... I don't know if I want to rename them. No, let's just pass all cages and killer cages through like that. It makes more sense. Selected cage. Right. So then we can just re-extract those on the other side. Do this. And then print that out here. And then instead of doing these, right, if selected cage undefined, cage equals selected cage, or just use, yeah, no, that's fine. And now I can select this. Yeah, no selected cage. This. We have a selected cage, and it updates. If we have 2, no selected cage. If we have this, but 1 selected cage, not a selected cage. All right, so that gets rid of all of this. So that's already done. This is probably not that necessary. Maybe. I don't know how CPU intensive this is. Probably not enough to ever be a problem. Okay, so now that's cleaner. Now what we can do with that is we can get a cage index, right? Because all cages should always be the same order. So let cage idx equals all cages dot index of selected cage, and we'll do that in here, and then we can output that. So now we have a cage identifier, and now we can reference that into our cage includes, excludes, whatever. So boom, and later on we probably want to cache that, you know, on puzzle load, sort it out then, because obviously the cases shouldn't change during puzzle running. But in the future, they might. Who knows, right? I have some ideas for more dynamic puzzling. So, cage index -1. That's because it's transformed. Ouch. Yeah. Well, I guess we can just do it on killer cages only. Index, 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 1, 1, 1. Okay. So this dot cages. Okay. So what do we want to do? We basically data set data cage equals cage idx. Right. So now when we're doing the whole handle click details part, right? Tag name equals span, digit. So val, change. Let's change it while we're here. So event target dot data set. I don't think that actually outputs what's in it. If I click that data set, DOM string false, DOM string map, data set dot. Ah, wait, okay. So here we're looking at the digits only. All right, so log cage slash val. So that's our target, but our target here could be all sorts of things, right? And we have span, okay. And then I think there's a query selector in the upwards direction. One second, there's some messages. Mark. And doing programming. So I think there is a query selector nearest, query selector parent. I think there's a way of selecting parents. Find parent by class, but I don't want to iteratively do that. Closest, yes, I think closest. So dot closest li. I think that's the one. All right. So let li equals, yeah. Ah, but what does it do when we're actually clicking on the li? Closest. Wait. Oh, okay. It currently only looks for the span clicks here. The problem is, could I click on... What else do we have here? Could I be accidentally clicking on the... Are there only spans and LIs in the way? Span LI. I mean, there are the potential pseudo elements. And if I click in between... Well, we can also do this, right? can do this and this. Okay. Yeah, we don't actually care about this right now, right? We just care about this. So li is that. And now we want to look at li.data.cage, right? Can I read property cage? Or is it data set.cage? Okay. All right. Hey. So, what did we call it? This dot cages. Okay. So this dot cages. So let cage ID equals this. Page ID. Let page info equals this cage's cage ID equals this or that or that. Okay. And cage info. We'll just have a look at this. We don't actually care about this right now. So we're here, and I'm pressing the 1. So our cage info is like this. And then here we're gonna do an inc and exc, like that. Include and exclude lists. And now, I'm almost thinking that the cage is complex enough that it almost warrants its own little object with properties and all of this. So we just tell it, hey cage, boom, include this value, right? And it figures out the classes and all this stuff. We probably shouldn't be looking at these at all now. We should just look at these two lists. Right. So we can also do let inc exc equals cage info. Inc exc. Okay. So clicking on the 8, we have inc exc 8 here. So now, basically, what we're gonna do is, instead of looking at the classes here, which we're not actually changing here anyways, right? Yeah, we're not changing classes here. So we can ignore all of this, basically. And now, based on the value, and are we gonna normalize everything to strings? Yes. So based on the value, if inc.index of val or includes val, then inc.splice inc.index of val 1. I'm going to remove that value and exc.push val. All right. And then else if exclude includes it, we're just going to splice it from the exclude list. Right. Else we're adding it to the include list. It's the same as before, but instead of the global lists, we're doing the per cage list down here. So if I click on a 7 here now, it should go from nothing to that. And if I click the 7 again, it should put the 7 in the exclude list. And now from here, from the exclude list, include splice exclude. So from the include it goes to the exclude. From the exclude it goes away, and from away it goes into the include list. So clicking the 7 once, include list, exclude list, neither, include, exclude, neither. Okay, I was looking at these digits here. Okay, now in our update call, we need to actually look at these lists. So now in our update call, we have an cage index of 5, right? Right, and now we can do let cage info, and we'll do the same thing that we did down here with cage info and the include exclude list, right? So cage info equals this cage is cage IDX. Instead of IDX, I'm just going to call it ID. Okay. And then we can do this cage, we do cage ID, cage info, inc, exc, and cage. Finally, the actual physical cage, quote unquote. I'm doing air quotes right now. Oh, didn't like that at all because I got rid of index. 104 cage ID. All right. So come here. Cage ID is 5. Clicking the 7. All right. So now the include exclude stuff, instead of using this inc digits, cage digits, yada yada yada, we'll do inc digits, x digits, x digits. And include vowels are used in 2 places. All right. And then instead of cage digits, might as well fully transform these to the nomenclature val or value. Now we'll go 7 crust, 9, 8. Okay, if we go here. Yeah, now one problem is by not looking at the styling here, we're not taking into consideration this sort of temporary handling of this stuff. So actually we might want to look at the styling after all, but now we have to clean up after ourselves, right? Because previously I think that was the problem, that you could, because here for example I'm assuming we can just remove it from here and that's it. We don't do anything else, right? And I think in this case it wouldn't even be in that list. Now, I mean, there's something else you could say. Is you could say, if I click on the 8 here, I actually want to remove the 8 from the cage, but I don't really want to go that far. Let's do something here. Wait, so event.target, li, cage ID, li, we don't use it anywhere else. Let class list equals event.target. So then we can do this here. And then instead of that, right? And then we clean up completely. We probably want to exclude, remove it from here as well, just to make sure, you know, we don't add it twice. And then we'll do the same thing with this. We switch that over from the exclude to the include. And here we want, if it contains exclude, we still want to remove it from both. Include, exclude. We want to remove it from both. We just don't want to have it anywhere. We're just clearing everything out. And if it's in, if neither of those is true, we're pushing it into the include. Now, neither of these being true, means neutral. Yeah, so that should be correct. And this one avoids the double pushing. I mean, we can just do this as well. If equals -1, then we'll do a push into exclude. All right. So now, if I go here, all right, I'm crossing out 9, but I can't modify. Oh, I can modify the 7. That's awkward. That is awkward. We might have to do a strict check. So if class list contains include and inc.and, we might have to do both. Includes includes val. So basically, if the class agrees, only if the class agrees with the value. And same here, and exclude includes val. And then else, the problem is the else now has to be also strict. When do we want to include? We want to include if this is not true. Let me think. If these are different from each other, we actually don't want to do anything here. So maybe that's the easier thing to do. So if class list contains include equals if class list let class inc equals that class x equals exclude. So if class inc equals inc class inc that, and it's simple. It's simple. It's just there's a bunch of it, and class x equals x includes val, and the throwing the word the includes in the middle of excludes and includes is a bit of a confusion for me. All right, so if they agree, only then do we do anything, and then we can do if inc includes, if x includes. So we don't want to do anything if they don't agree, because that means the internal state is overridden with the state on the board, in which case, like, you cannot exclude a 7 that's clearly in the cage. You just can't. And I hope people won't get confused by them clicking the 7 here, trying to remove it from the cage, you know? And now we can rely that we're only modifying the state when it's consistent. So if the classes agree with us here, and that also means that if the 7 is included and it's here, clicking here will make the classes disagree. Will that override that? That's the problem. We actually get we can potentially have an agreement there. I'm starting to wonder if having the digits permanently override what's in the list. So in other words, imagine I have this, right? Now I say, okay, force this. Now if I put the 7 here, I say, okay, now I know where the 7 goes. It should wipe it from the include list, or add it to the include list. Or if I remove the 7, should it then clear it from here? That's the question. Guess Mark has left. Nobody's helping me. Or my chat is not working properly, which is also possible. This is the little itty gritty stuff that's actually really hard to think about until you actually use the tool. Because right now, with this setting, what would happen is, imagine I set the 7, I go here, I put the 7, now they agree, now I can click this to exclude it, which shouldn't be possible, it doesn't make any sense. The thing is, I don't actually, without looking into the cage directly, I don't know how to prevent that. Or without marking that we have this sort of temporary thing going on. I mean, I could, every time I update it, I could actually update the digits in the cage as well, and then take them into consideration. And then basically say, hey, if this is part of the cell digits, just don't touch. While the digits are in the cage, don't touch their state. The thing is, at this point, are we including or excluding that 7 here? Yeah, 0 out of 6 combinations, which obviously doesn't make any sense, right? So if there's a 7 here, we should actually wipe the exclude, we should remove those from the exclude state, right? So I think the cage values should override our internal values. So if I'm removing the 7, then the 7 include should go away. No, it would stick. That's the other problem. The 7 include then would stick, which is also not what we want, right? So if we're in this state, I can go here, put in a 7, it goes green. I remove the 7, it should go away. But if I do this, and then go here, add a 7, remove the 7, it shouldn't go away. All right. Let's do this. And let's turn that into a small function. Get cage info. So, literally, it's just going to be this one line here. I'm mostly doing this to not have the code folding go all screwy on me. All right. This.get cage info. Right. Cage ID. Cage ID. Let's simplify all that. Get rid of that. And probably can do this. Boom. All right. Now, when we get to here, we're going to update the cage info with the vowels, right? And then we can do inc blah, 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 yada, 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 vowels, cage vowels. So we do vowels dot splice from 0, vowels.length, and cage vowels. Have to be careful because vowels is super generic. In fact, I think I'm going to call these cage vowels here. Cage vowels, and da-da-da. I'm thinking of, is it worthwhile wrapping this into a function? Get cage vowels, p.get cage vowels function cage. And then later on, maybe I can wrap all this stuff with the cage info stuff into a update cage info type thing. Do return cage.cells map, yada, yada, yada. So then any kind of whatever we can do in there. And then cage vowels here. We'll do this dot get cage vowels cage, right? And then this is actually cage vowels. And then we can output cage vowels here. And that will already be correct then, in theory. Unless it blows up. All right, 232. 232. Oh. Uh-oh. Where did I go wrong? Where did I go so wrong? That looks right. That looks fine. That looks fine. Did I halfway start doing something here? Yes, I did exactly that. And then stop halfway through. Vowels is not defined. Cage 93. 93. Cage vowels. Basically, the idea is that I'm deleting all the values that are currently on the array and replacing it with new values. Not sure where this is happening. 93, 95. Why is this nothing and this an array? Cage vowels should be an array, right? Cage vowels. I'm not reusing this somewhere else. Cage info. That should always initialize cage vowels with an empty array. That looks fine. Yeah. No. Get cage vowels. So this probably needs to do that. Okay. 9. Cage vowels has a 9 in it. Okay. Cage vowels nothing in it. Cage vowels has 9 in it. 8. So it had 9 in it. Now it has an 8 and 9 in it. Okay, because now we can use the cage vowels down here. Cage vowels. Cage info. Cage vowels. All right. And now we can say if this is inside cage vowels, we just don't do anything with it. But do we want to remove it from the list? That's the question. Or do we just not touch it? Like, we could leave it on the exclude list. So in other words, right, let's say we're in this state, we could exclude the 9, then put the 9 in, then that would override the exclude. But the moment you remove the 9, the 9 would go back into the exclude list. Or we override the exclude, right? And not override the include, because the include doesn't conflict. The exclude is what conflicts. Or, putting the 9 here, we could override it temporarily, and we remove it, it'll be back into the exclude list. I don't know. We'll get to that in a moment. So, click details. So we go here. So we have click details. Here, cage info, before and after, cage vowels, cage info, include, exclude, and cage vowels. Cage vowels. Right. So, if cage vowels dot includes val, do we then just exit out? No. If not that, then we do this update. Shenanigans. Otherwise we don't. And we don't look at the classes after all. Okay, I think we have an erroneous instruction in the puzzle again somehow. So we go in here. We're including the 8. We go in here. We're putting an 8 in. Now clicking this shouldn't do anything. Now deleting the 8. We still have it there. Now we have an excluding an 8. Putting an 8 in here. Okay, now at this point the 8 should override what's in here. Because now it's asking for an include and an exclude at the same time. Okay, but that's now on the other function to deal with. Okay. All right, so now the question is, if we have a cage value and it's conflicting with one of the other items, so I'm just having a discussion in Ethereum program because I'm wondering if there's an automated way that you can transform a difficult puzzle into a slightly easier one for somebody like, you know, hey, this is too hard, boom. For example, turning a 9x9 into a 6x6, because you can turn a 6x6 into a 9x9. So I was wondering if there was some sort of reverse transformation you could do. It would be quite interesting as an automated, you know, button you can press for people to say, ah, I'm struggling with this. Because personally, I find very hard classics quite frustrating, more so than hard puzzles with complex rule sets. All right, I think we can do this a little bit. I think I need a break soon. My brain is not working at full speed. Even though I feel like I started pretty late today because we had a morning session with the dog out at the beach. So, ooh, somebody commented on my tweet. When did I start? Just before noon. Interesting. All right. Focus. Focus. So we said including it should definitely at least let's start with overriding the excluded ones, right? So the same way we have inc vals, we should create an xvals function. Right? And I think doing this might not be necessary, but it also won't necessarily harm it. So we can do inc vals and xvals. And xvals will be a little simpler. It'll be x dot filter cage vals dot includes val. So if cage val doesn't include the val, we'll keep it. And that should give us a new inc vals and x vals list. Cage vals equals x vals. Right, so now let's say we go here, we're excluding a 7. Now the lists are no longer global. In fact, let's get rid of the global lists. Inc digits, x digits. Those should no longer appear anywhere, right? So we have include vals 8. We get rid of this, right? And let's say we're excluding the 7. But now we're putting a 7 in. Inc vals, x vals. So we have now an inc vals of 7. If we remove it, we have an x vals. All right. So then, instead of using x here, we're just going to change all of these to using x vals. So, boom, we're in here. All these combinations. Let's say we're including a 9 and an 8. But now we want to exclude a 7. Get rid of the 8. So if we put in a 7, it overrides the exclude. But if we get out of it, it comes back. We're including a 9. Now I can't toggle the 9, but I can remove it, and now I can toggle the 9. Now if I put a 7 in, I cannot toggle the 7. If I remove the 7, I can toggle the 7 again. Oh. Did toggling the 7 just remove the 8? Wait. Huh? That definitely looked like it excluded the 7 here. So wait, 8, 7, 7, 7. What happens there on the last one? We should look at cage info, right? 87 nothing. So if cage val includes val, cage vals is nothing here, right? I think we're transitioning from an include to an exclude on val. And then we're transitioning from an exclude to an include on val. And then from none to include, right? So the 7, 8, 7, clear. That removed the 8. So from exclude to include, wait, what? Clear. So from exclude to include on the 7. No. From exclude to none. Okay. And we went from 8, 7 to... okay. We don't need that anymore. And this should also always work now. Okay. 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 So 9, exclude 7, include 8. But if we put a 7, now it needs to include a 7, 8, and a 9. And basically we only have that option at the top. But if I remove the 8, now we have the 1, remove the 7. Now we have an exclusion on the 7 from earlier. Right. So we might consider removing that exclusion automatically, but I'm not sure if that's the right option here. All right, it's slowly getting there. It's slowly getting there. It feels a little painful, a little too slow for my tastes, but I think this is now working as intended. So I think now we can go back to concentrating on the row handling. All right, so we still have a potential for so this get combinations I think currently is out of order. Little double underscore just to remind ourselves. We still have the option of removing the rows altogether. The only issue with that right now is how to bring them back. We could add a row of filtered digits at the top. So instead of having the coloring in here, we could have the coloring at the top. And I'm wondering if this is partially a preference because of how it's done in others. I'm wondering why this allows... How do I exclude more than one digit? Oh, different ones. So there's no other things allowed. Yeah, I don't know why this wouldn't be just... Because now if I say, okay, it must include a 2 and it must exclude a 2. It lets me do that, which doesn't make a lot of sense, obviously. It might temporarily make sense, I guess, while you're doing other things elsewhere. Min-max size info. Don't know. So I could say between 2 and 4 and 30 and or 10. Yeah, min-max might be handy. Yeah, but I think there comes also a point where my tool doesn't have to do everything. I'm not trying to replace one of these generic tools. It needs to cover 95% of the cases and do those 3 times as easily. That's kind of the goal. All right. Right now, I'm still not sure what's included and what's excluded. So we have that invalid style. The problem is to override the digits themselves. So if I do something like span and then do opacity 0.7, for example, is that enough to just make these less highlighted, if you know what I mean? So I go here and then put an 8 in here. Do that. Maybe. I mean, you can still where they are. I'm also finding that black fat digit to be a little bit too, maybe too strong. What if I move some of these styles higher to the LI here? Like this. What if I do this? Also, the default white on that light gray background is a little... Let's see. What if I make this a little darker? If I do this triple B and then make the dark one even darker. Like that. Like that. Now the final one is to actually mark these, right? So we need another item for excluded combinations. So xcombs, right? So now if I look at here, cage info, event.target dataset.cage, right? We look at this, and I select this. We've got excluded comps, right? And if I do xcombs, and I think we can do two things. We can ID the combinations, which I think is fine because the combinations will always be sort of static, like they're not going to change. So what we can do is we have a cage ID, and then we can do data.comb equals, and this will be this. Now rep combination, is this all comms? Yeah, so this is always relative to all comms. Comp ID. So we can put that in there. And cage and comp. Okay, so we can do something like let comp as comp ID and cage as cage ID equals here. All right, and then we can do cage ID, comp ID, and separate them by the comma. All right, and then that'll be cage ID. So if I click on that, we should get a 9 and a 2. cage underscore for that, and combination 2. If I click this, combination 0. If I click this, combination 5. Okay. And then here, kind of do the same thing. Except we'll do it on this guy. And then we'll do cage ID here. And I feel I'm getting this wrong somehow. So what do we get? Cage ID 9, combination ID 1. Okay. Cage ID. Data set. Why doesn't that work? Cage ID 1. Cage vals 2. Oh, because I keep clicking. Yeah, so this is the sort of things like, why isn't it working? Because I'm not actually selecting this cage, and I don't actually know why it thinks that cage is the one that's selected. And I have a feeling the selection doesn't get updated correctly. So if I do framework.app.selected cells, no, .puzzle.selected, there is a selected cell. Why is it not visible that it's selected on the screen? So there's something is happening where the last selection is not shown. Interesting. Why is it resetting? If I do this, right, and I refresh, now this is selected. So it remembers that there's a selection here, but it's not marked when I'm reloading. All right. Anyway, so we now want to go here. Excluded combinations. If, and we can probably do that as well. Cage info. Can probably just do this as well. Right here. Then we can do xcombs. If not xcombs dot includes comp ID, xcombs dot push comp ID. So now we're pushing the combination ID into that thing. Boom. Now if I click something else, or if I click 3 and 2, 3, 2, 3, 2, all right. And we just kind of want to toggle it, right? At this point, we just want to toggle it. The question is, do we have the same? Oh, 1 second. 1 second. Somebody rang our doorbell by mistake, and our dog gets very happy and excited. All right, so Where was I? Where was I? Ah, yes, the excluded combinations. So the question here is, do we want to blindly toggle it, irrespective if the combination is actually excluded by the filters? Or do we want to remember the exclusion, but not touch it? Because it could get confusing that, let's say, I come here, right? I have these excluded. I click on it. It's actually toggling it. I click on it again, I toggle it again, and I leave, and things aren't, or I change this, and then things don't reset the way I thought they should. Or for example, let's say I exclude this, and I put an 8 in there, right? Now I remove the 8 again. Should my exclusions be remembered? Yes, no, maybe? I don't know. Hey, Mark. Yeah, I have a lot of issues with the sort of overrides and how to handle them. So for example, it seems to be very common for these tools that you can mark your things. Now, I'd like to not have two different kinds of markers, i.e. the marker that you manually set versus the marker created by the circumstance of the software. I'd like to make that the same, but then you get into the difficulty of what happens when you click something that's currently excluded by the filter. Hey, Anshuman. So I could have a secondary marker, like I could literally have a checkbox here. And that would be super explicit and it might make more sense. Well, for now, let's just do a blind toggle. So we can do, if it's included, we remove it, else we include it. Right? So if it includes it, then splice. It's a pity that you don't just have delete item as a function. It seems to be like a no-brainer that you have to do all this. So if I do this now, click this. So I can exclude these, and then I can exclude this, and then I can toggle them all at will. Okay, and now we'll just have to reflect the excluded combinations up here. Cage info we don't actually need, so we can get rid of that. We need excluded combinations, right? And dataset, yada yada yada. If valid comps.includes comp. So now, should the summary reflect your manual exclusions? I think it should. Okay, this was a bit, let's see, size 3, 17, okay. So if I exclude this, possible is 7, 6, yeah. So I should, missing 1, 2, 6. Ah, that's interesting. That's maybe some information. So, by excluding these, those are the digits that aren't used. Required. 359. So if I do this, we have a 3. Ah, okay, so it's the required are the digits that are common. Okay. I mean, these are additional bits. Again, like I don't want to have a complex UI like that. I'd like to keep it as simple as possible. All right. So for now, I'm just gonna merge it with valid combinations up here. So basically, filter by combinations and then filter comb. Actually, we filter that first, right? Because we're filtering by IDs. So we have comb ID, and we'll have excluded combinations from here. Not dot includes comp ID. I believe. I think the comp ID is the index basically, right? So I can click here. Oh, no. Filter not includes 85. Oh, yeah. All right. So we're here on this cage, and I can exclude. Nope. Apparently not. So we'll have the excluded combinations. And then here we have valid combinations. These don't seem to be jiving just yet. Boom. Clicking here. It doesn't trigger an update either. That's a bit odd. Is the update happening in here? Oh, okay. Okay. Ah, yes. All right. Still have to fire an update here. So we're here. I can. No, still not working. Excluded 2 valid combinations are these. If I exclude 1 and 2. Okay, so that filter operation doesn't seem to work at all. Filter combination, exclude combinations, includes comp ID because they're strings. All right. You probably wanna parse int comp ID. All right. Are we using cage IDs for anything else? Cage ID, get cage info. I think get cage info is using. Yeah, so those would be fine. All right. So we're on this cage. I manually exclude these now. I go away. I come back. I exclude 5s. So that manually excludes those. I remove the 9, which brings this one back. I've manually excluded this one, which I cannot toggle. And that's because I'm parsing inting over here and then they don't match up. All right. Comp ID. Do that again. So include 7s, exclude 4s, manually exclude these. And because of the include, it doesn't care. So that's the thing, right? So right now I can toggle it. If I include the 7, I can't toggle it. I can toggle this one. Should I toggle underneath when it's forced include? Or should I add an extra symbol here to mark this as manually added or removed and or toggled, right? So they have these guys here. I mean, I could easily do a plus minus in a little thing. I could probably do this with mostly pure CSS. So right now we have these guys here. We have this class here. I think I don't actually mind having an empty class definition here. And then we'll just do this. No, not this. We do this. And then here we have invalid. Right. And we also potentially have and we also potentially have, so instead of merging it into the valid thing here, which we need to do anyways, right? We have excluded combo. whoops, excluded combo includes comp ID, invalid, excluded. Okay. So now, if I go here, oh, it's completely broken. Ah, no plus here. So now we can go here. We go here, manually exclude it, but we say, so we have two excludeds. And now if we look at the styling, we have invalid and excluded. And then on the excluded one, so we have invalid here, and then we'll do this kind of shenanigans here. Invalid span, and then now we do li exclude, and maybe we'll not be lazy. We'll let exclude, make it, we're gonna make it something, content. Is there a Unicode plus with a circle? You know what? No. We're gonna do a plus, a simple plus. We're gonna do no transformation. We're gonna not do any of that. We're gonna do border 1px solid black. We're gonna do a border radius 50%, and that should give us a circle. Hey, sort of. Sort of. Okay. The funny thing is, exclude. Where are all of these excluded? Oh, did I invert my check here? So if I do this not, and then I invert these like that. All right. So now, why are these not round? We probably need to force the size on these guys. Okay. Well, the whole thing is how high? 1.4. So what if we do width 1 rem, height 1 rem. Okay. Line height 1 rem. And can we just go to this guy, do something like, look at the right thing here. Exclude, yeah. Vertical, align, middle. Come on, vertical, and then middle. Vertical, align, middle. Margin, auto. Margin 2 rem. Display block position absolute. Position absolute. Width height. Position absolute. Margin. Why is the text shifted like that? God damn it. We have line height 1. Text align center. Vertical align middle. Top 0.2 rem. Now it's a 1 rem item in a 1.4 rem, so the 0.2 rem positioning should center it. Oh. It doesn't center it, so margin top. Can we do that? All right, it's getting there. Can I embiggen this? Margin top 0.2. There's a little bit of a misalignment here. So this thing here is supposedly, so the LI is supposedly, where is it? Not grid, not flexbox. Nope. Where's this? Yeah. So it's supposed to be, so this 26.6, and then this should be 16, which is much smaller. Because this LI is supposed to be 1 point... font size. Wait a second. What height is it? Line height. 1.3. Line height. If this is 1.3... This is 1.3. And it has... a 1 pixel border. And this is... man, my brain. Font size 1.3. If I do this... 1.3... Oh, my brain. This is maths, isn't it? Snuck up on me. Line height 1. If I don't position it absolute... The thing is, I don't want this to take up space in the thing. What if I position this relative to the LI? Relative. And I'll say margin top minus 50%, and then top 50%, and make it in percentages. Hey, Mark. Do you have before after? This is the before. I'm not sure what you mean with do I have before after border box. Ugh. So I'm guessing these are exactly the opposite. So the top here is relative to the box rather than to the element. So top 50. So margin top minus 50. So if I do this 50, I want the margin to be relative to the LI. Is that hard to... Is that too much to ask for? But it's using the parent. The top 50. I could use a transform. Ah, wait, but I know what our size is, so I can say minus 0.5 rem. And that kind of does the trick. Okay. So minus 0.5 rem on the margin. Top 50%. Okay. It's still not centered. We probably want to make it a little bigger. And we probably need to adjust the font size. Font size 1.2 rem. And then this would be 0.6. What does that look like? Yeah. That kind of works. Font size can actually be a little bit bigger than this, I guess. Although I don't know if that then pushes it off center. And text align center. That should do the trick for horizontal alignment, right? I mean, it doesn't look properly aligned here, to be honest. Like the text. Let's see, vertical align, text align. If I don't do it centered, it doesn't seem to make a difference here. Font size 1.4. It's just to mostly ignore all of this. If I do this 1.2. Okay. 1. Okay, it makes it smaller. Okay, I'm guessing these alignments don't matter because they're inherited from something higher up. Okay, well, now if we get rid of the red background and the plus minus here, it's basically the same color as everything else, right? So if we make these white. And what do we get? Okay. Then if we do details li like this, and I think we need to do the opposite, right? So minus is the default, and then, yeah, so when we press it, it excludes it, right? So if we press it, it excludes it, and when we plus it, it comes back. Like that. Okay, it's always a bit of a annoyance, because does it indicate the state or does it indicate what it does? Yeah, I mean, I could probably draw the plus and minus as in borders or something like that, but I'm not gonna. So I think this all is no longer necessary. And we probably want it on the right side. So we can do something like right 0.5 rem. Oop. What do you think? I'm gonna put an 8 in here, exclude the 7s, manually exclude this one, and now we have one cage that we have selected, for example. And the plus will tell us that this is toggling even though it's excluded by this. Right, now if we remove the 8, we can add these back in, but because of the 7 here, these are excluded. And we can add this one in. Now we can say include a 9, okay, but exclude the 3s, all right, but ignore this one, for example. Now if I put a 6 in, I'll get that. If I put a 4 in, I get that. If I put 5 in, I get 2, I get that. If I put a 1 in, suddenly we have 0 out of blah, blah, blah combinations. Reason being, this is manually excluded. I think that kind of covers all the cases. Now, I feel like this is a little too dim. So we probably want to fiddle with that quite a bit. So this is the excluded cases. Include, exclude, include digit, include, exclude, background color, border color, font weight, before, yada, yada, yada. Okay. Invalid, opacity 0.4. So if I go to 0.6, yeah, I think that's better. Maybe it's even still a bit too faint. Ah, because of the 1, all right. Between a 5 or 6. Exclude that. Exclude 8s. So we have one option now. The colors grades are really confusing for me. I watch on iPhone now. What's confusing about them? Because everything that's represented by a color is also represented in another way. We have the strikeout, we have the bolding, we have the change of the color, and we have the plus and the minus. So what's confusing? What are you confusing with what? That's exactly the kind of feedback I need now. Let me just have a look quickly in this. I mean, I find the different shades and stuff make things a little hard to see for my eyes. But this is not the primary puzzling UI. So that's not necessarily untenable. Well, I changed it to how you asked me to change it. Before it was reversed, and I reversed it for you, and I disagreed with that. Because to me, a white was a highlight, you know, like the white on a link. So that, to me, black is a text, sort of a background default, and then white means, like on the buttons, it means highlighted. And you said you wanted it the other way around, so now I made white the other way around, right? So white is now the default, and it becomes black when it's activated. Have you changed your mind again? Yeah, to me, the default situation should be black text. Like this shouldn't be, it shouldn't look like this. The white text should be the disabled text because it's, well, I'm just contradicting myself. I think the default text should be black. Then we can highlight it in white. And then when we're disabling, we just want to fade it out. So I'm going to try default black again. Also, the contrast is a lot easier, right? So now we can make the backgrounds a bit lighter, because before I had to make the background darker to contrast with the white text, so it's even reasonable at all. So now the LI background, let's put the colors together after all the fuffing about. So we can do this brighter now, B, C, D, let's say. And the overall background, we could make it potentially brighter as well. So it's currently a semi-transparent E. I don't want to make it bright. I don't want to make it an F. EF. Okay, so let's make this a C. And then this should not doesn't necessarily have to be this dark now, because the other one is brighter, right? So Invalid can now be a bit brighter. Let's try an A. Okay. And then if we're doing this, this now should become a 0 on the text, or maybe slightly dimmer than a 0. Sorry, a white, right? So we have this. So now we want to make the background darker to contrast it, because right now it's all on a white, on a very bright background. So the background color here needs to be darker. So we make it less transparent because it's already quite dark. So that makes the green stand out. And then this, now we have to mix it with the darkened background, right? Because it's already, the opacity is reduced, right? So we don't want to make the effect too dim here, because then we have double opacity bollocking going on, which kind of adds up. So for the excluded digit, wait, why does the before have a background color? Oh, because that's the line, the strike through, right? I think we don't even want to make these transparent now. The background maybe yes, or a little bit of mixing. So basically now we have to remix the red colors to fit on the darker background, because they will always be on that background. Because an excluded digit is always in an excluded row, right? So I'm gonna adjust it according to this. So it's now dark, which means the red needs to be bright. So we did a 9 on the white before. Much brighter than that. Maybe a B even. Much brighter than that. So maybe a EC, maybe a D99. Like that. To compete with the green, which needs to be a bit darker. And the border color is black, which is fine. So now we can make these somewhat transparent, maybe. All right, and then maybe this only a tiny bit transparent, like that. Ooh, already too transparent. Ah, wait, tiny bit is on the other side of the scale. So a 0C maybe. So I think they're both easily recognizable in either background color now. In fact, I might get away with making the red slightly less visible. So instead of a 9 here, maybe make it an 8. And then C, maybe a B instead of a C. Like that. So we're gonna go here. Green, red. Okay, what do you think about these colors now? So we basically inverted the yeah. in fact, the white on the 8. I'm almost wondering about the bolding, making it less easy to read. I don't know. Maybe we don't need the 600 font weight on the enable. I mean, you know, as what was his name? As Even said, bolding is a signal of positivity, right? Of acknowledgement per se. So, why is this one? Ah, because it doesn't have a 6. All right. Well, if we have a 7 inclusion here, then we can do this. So the 7, what do you think on the white digits? Bold them or not bold them? So let me see what else we can tune. So we could make the green a bit darker to make the digits stand out more. We could make the border color less transparent. Oh, no, we can't actually. I mean, we could make it not transparent at all. Yeah. And I think for colorblind people, the black versus white should be enough as well. Now, the other question is, should this all be persisted? So if I press refresh now, it feels like this is almost has to be part of the game state. Although I don't think I want to keep it in a replay, to be honest. I don't think it's replay part, because it's specific to one aspect of the puzzles, right? And I need a way of disabling them more easily than, because, you know, if I have a non-killer puzzle right now, let's say this one, I mean, you know, although it doesn't disrupt either. Okay, I've just noticed that the sizing doesn't seem to be independent. Yeah, there's a point where that space increases. Like, I'm trying to squeeze it into a space which is really too small for it. Like, so I don't have to change the layouting on mobile, you know? And that I can reuse the same layout without having the fact that the calculator's on, you know, that it doesn't affect the layout. I'm wondering if the disabled state should fade it a little more. The invalid rows. Where are the invalid rows? Include digit, include invalid. But I had it 0.6 before, and I didn't like it. Maybe. Maybe. One other thing we could do is we could have a border around the valid rows to kind of highlight them a little bit. The problem is when it's all alternating like that, it's a toss-up, which is the signal and which one isn't. I mean, we could also do a strike through on the whole row, similar to what we did for the individual cells. Yeah, I mean, it's fainted right now because I just changed the opacity of the whole thing. What do you feel? How do you feel about doing a full strike through of the invalid row? So if we do li.invalid before. Wait, first of all, can I move this into an after? Otherwise, we're gonna have a double here. Can this be in an after? Wait, what? Oh. I was like, what's going on here? Alright, we can put this into an after, I think. Yeah. So then in the before, we could potentially do a full strike through. Like that. 355. Sort of. Sort of. actually not terrible. We probably don't want it to be the full 100%. Top 50 yada yada minus plus 10%. What if we do this? 60, 60, 20. Yeah, so I strike through it. If done tastefully. Yeah, one of the problems is right now it'll be centered on the cell, which doesn't take this into consideration. And it'll give us a problem with very large cages. In fact, that's something we need to look at because I have that overlay on the right side. Where's our test board with big cages? No. Nope. Nope. Wait, what? How's this puzzle not found? What's going on here? Load remote CTC. Uh-oh. Oh, alright. Good that I scrolled through a couple of guys here. So 48, get cages. Get cages, line 48. So I'm guessing these are cages without a cage value. This splitter should really handle that better. Yeah. So if we don't have a cage value, they should be filtered out. Should they? Not necessarily, right? Because if we don't have a cage value, we might not be able to calculate the sum, but we can still reduce our possibilities. And this is kind of, it goes back to sort of min-max, right? How are we gonna handle that? Like, it doesn't make, because, you know, just because the sum is known doesn't mean it doesn't have a sum, right? And the other tool handles that by basically having a min-max, right? So I can say, I know it's a size 3, and it just gives everything with size 3. And it tells you, okay, the total can be between 8 and 24. So I feel like we kind of want to handle that. So we can do something like let cage info equal return cage info, and then if cage.value is not equal defined, we'll do this, and cage info dot value equals val, and then we can do something similar if cage.sum is not equals to undefined, then cage info dot sum cage.sum, right? And then the same with unique. Cage.unique is undefined, unique, 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 boom. So if we do that, now it'll break somewhere else. Wait, is this the one? No, it's not the one we had a 4 on. This one. So we have that. Now if I just select the cage, okay, so we have some undefined. So in this case, and I feel like I'm moving very quickly on to a new feature. In this case, we basically want to do a min-max calculation, which the other tool supports, which I originally wasn't planning to support. So if I select a cage, right. So we are calculating Filter comp by vals. Get killer combinations. So get killer combinations. How do we update that function to accept ranges? If digits include sum. So first of all, we can remove this because we can simply say if size equals 0, we return empty solutions, right? Or if n is greater than 0, greater or equal to sum break. So this is all using the sum to exit, but really our exit is when we're running out of digits or we're running out of size elements. So the cage size should always be, well, not necessarily. I mean, they accept a range of cage sizes as well. So as long as we have an upper limit, right? So how do we generalize this algorithm? First of all, let's not break our existing algorithm. So we're going to create a second one. Right, killer combinations 2. All right. And now I think we're just going to do something like args. Args. Options. And we're going to output some things. Like this. And we're just going to run it in parallel. Now, I'm not going to be able to finish this. I'm going to need a break. But we're going to run it in parallel with the other one. And we're going to basically do c dot. And then we're going to fill it in with some stuff. With some options. And the options will now be, and the included excluded stuff happens afterwards, right? So here we're just going to calculate all of them. And as we saw earlier, the maximum number is 405, right? So if we have to do them all, it's not a huge deal. So now you're going to pull all those things out of the options. We're going to give them some defaults, right? So we have min sum, max sum, min size, max size. And before we pass in the digits, I'm gonna skip that step because I don't think that's useful, even though we passed them in here. Yeah, I don't think we need to pass them in at all. Doesn't make sense here. All right. So min sum. And that's math dot. What is math.min of 0 and undefined? Math.min 0 undefined. Not a number, huh? So what about h.sum? H.sum else 0? In theory, I guess. Max sum, cage sum, or 45. But here we can get smarter and do it rows by times columns and all that sort of thing, or triangular number of whatever, right? Right now, let's make it work for 9 by 9s. As long as we don't have multi-digit support, it would be very hard to properly support other sizes. Anyways. Because letters and so on, you know, they don't really... In fact, this algorithm should work without sums altogether, because it can just give us combinations, right? Given a set of letters, you know, how many combinations of 3 letters are there, right? and it can just calculate them all. And then you can say, okay, but what if they have to include a C and cannot include a D? So the combinatorics of it all doesn't really depend on the sums. All right, and then min size and I think size are more important. And I think right now we're just gonna pass in size. And then we can pass in sum. And if it's undefined, you know, we'll look at the min, max, and all that stuff. So here we can do size, sum, and then we'll look at all of those. Right? And that should get us something. Boom. Cage value equals undefined. Where is this coming from? 73, 74, 73, 74. No. Get cages. Alright. Get killer combinations. Number 2. Alright. So 0.45, undefined, undefined. Min size, max size, sum. Size, min size, max size, yada yada yada. All right. I actually want to output these one by one so I can see them more clearly. Right? Well, we can maybe do this actually. I think that makes sense. All right. And then we basically need to look at these accordingly as we're going through our options. Let me see if there's anything happening on Twitch chat. So far, so good. Oh, Restream chat's finally seems to be updating. Very nice. I mean, better late than never, I suppose. Now, here I was trusting on the recursion to eventually end up at size whatever. Now we want to go the other way around. We basically want to exit when our solution has reached exceeds our maximum size. And our combinations, we always start with a pool of digits. So when we're done allocating digits, you know, that's when we finish, right? So we have a search tree. Let's look at it this way, right? We have a search tree that's 9 digits deep. So we kind of find all the combinations that have a 1 in them. Then we find all the combinations that have a 2 in them, etc. And then we find all the combinations that have you know, 1 and a 2 in them. Combinations that have 1 and a 3 in them, etc., etc. And we basically need to figure out how to exit the quickest. All right. So our previous exit strategy was we've exceeded the sum or we've exceeded the size. Now we have another exit strategy. Basically, we have minimum sum, maximum sum, right? So I think what we're going to do is we're going to ignore sum, and we're going to simply use sum to initialize min sum, max sum if min sum, max sum aren't given. So basically, if min sum equals undefined, min sum equals sum, and equals sum. No, wait a second. And if it's still undefined, min sum will be equal to 0. All right. So same thing with max sum equals 45. Right. And we'll do the same thing with size. So min size, min size, min size, min size, max size, max size, max size, max size, and that's size. So minimum size is 1, and maximum size, we're just going to call it 9 for now. We're just going to do a standard killer Sudoku 9x9 tool, right? And then we're going to output these underneath and get rid of that. All right. So now basically, the moment our total sum is above minimum sum, we start recording potential solutions. And if the size is above minimum size. Otherwise, no. Right? So now basically we're going to say, okay, we're going to add numbers until we set size 9. The problem is we still have to search the entire tree. And that tree is large, isn't it? It's 9 plus 8, it's 9 factorial, right? 9 factorial? So that's 362,880 possible combinations. I mean, we can calculate that. It's not actually a big problem. So if we clear all of this, and we'll say size is 9. Yeah, basically it filters them all out. Now if the total is 100, or yeah, so it kind of filters them all out, because but I think there's no way to not search through the whole tree. Right. So if we're gonna do something like let vals equals, right? Now the question here is it faster if I, instead of having an array that I'm pushing into and out from, if I have something like an object with true false values on the digits? So we're not modifying an array. I'm just trying to think. We also have a binary search, and we never backtrack past the most recent digit, right? So we could literally have an index. We're looking at everything from 1 onwards. Then we're looking at everything from 2 onwards. You know, and that I just, so we basically, instead of using a recursive algorithm, you know, 300, well, it's only 10 levels deep. It's actually not that bad. We could do a linear algorithm, right? So let's do that as a little exercise. Linear algorithm here, no recursion, right? So let I equals 0, right? And then we go like, okay, or more accurately, for let I equals 0, I smaller than 9, I plus plus. That's our first level of so the first level is how many digits are in our have we already checked. And then the second recursion is the digits we are checking. And I think that's all we ever need. Or do we need more loops? Do we need 9 nested loops here? I'm just trying to think. Because obviously I can say, okay, for 1, now loop through everything after 2, and then loop everything after 3. But I feel like we can do this in another way as well. So let's start with just this. All right, so we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now we have a 1. We're adding that to our sum. So let our sum equals 0. And the idea would be that we're not adding things to an array until we have a solution, and then we add that solution to a solution array for sure. But we can also do this, or cur size, right? So we have a digit. We're gonna add it to our sum. So first of all, we're gonna do let val equals this, right? Cur sum plus equals val, and cur size plus plus, right? So now we can say, and here we're gonna do something like, I don't know, whatever. I val cur sum cur size, and now we're gonna do compare it to min max, right? So we're gonna do size, min size, max size, yada yada yada, and then car size greater or equal min size, and car size smaller equals max size. And basically when these trigger true, that's basically when we're gonna put it added to the solutions. So min size, min sum, max sum, and current sum. Right. We'll do the size first. And what does that look like? So sum undefined 0, true, 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 size true. So our current range for the size is 9. So size would always be false until we got to here. Because we kept adding 1 to the thing. All right, which was my intention. We haven't done the recursion here yet, right? So we're looking at 1. So here is where we would normally recurse, but instead of recursing, we're now looping from. And here's where my brain fails, right? So my idea is we have sort of a pointer at the current digit, and then we have a second pointer that traverses our tree down, and we have a pointer at each. Imagine the tree 9 wide, etc. So I think we need 9 pointers to know which way we've gone. Right? Let me see. So what I'm trying to say is nope. Can I draw? How do I draw? Maybe at the bottom. Here we go. All right, so we start, and then we have, we have our 9 digits. So 1, 2, 3, 4, 5, ... 9. Right. And we have 9 levels. So level 1, level 2. So here we go again. All right. And then we have 9 levels down this way. Right. So the idea is this counter is our 9 levels. So by the time when this reaches 9, we have gone through all possibilities, right? So the question now is, do we need another 1 through 9 for each of these? And I think we might have to, right? So we might have 9 counters, an array of 9 elements that slowly count up. So we start the array with all zeros. So mark, we do them all zeros, right? And we keep going until they're all 9s. So we started the first one, incremented by 1, make this a 1, go to the next one, increment by 1, then we go back, increment it until we hit the end, then we go back, increment it until it hits 9, then we go back, then we reset it, then we go back, etc., 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 right? And all we need is these numbers and an eye of which number we're currently looking at. Does that sound right? All right, I'm not going to start with a 9 wide. So let's start with a 1. All right. And I equals 0. So our value is mark I. And let's make it 2. Right. We haven't done anything yet, so we increment val. So let's not do anything with these, right? So val, or we increment mark I, plus plus. So the idea is, once mark I is 9, we reset it down and go back 1. And we keep going that until going back 1 gets us back to 0, which means all of them have reached 9. Right? So we're incrementing mark I, and then we're outputting mark I, mark I. And this is just one step. I'm just going to do it sort of manually, right? So 1, 0, and we'll keep doing that a couple of times. And we don't actually do that, right? Then, if mark I is greater than 2, right? Well, actually, we're incrementing mark I. We're doing this, then we're incrementing I. I think that's the first thing we'll do, right? Actually, we'll do this. Now, this is a bit low level, and I'm just kind of having fun here, to be honest. We'll start at the beginning, and then we'll do that. So we'll start with 0, 0. Now we're at 1, 2. If we do this, and this, and this, right? And this tells us, initially we had... no, these should be 0, 0, right? So we start with 0, 0. Then we get 0, 1. No, we should get 1, 0. So we get 1, 0. And now if we do it again, we'll get undefined to 1, 1. Okay. So that's good. So now we've done all the combinations. We've gone down the left side of our tree at the bottom. So now we have to back up. So if I is larger than whatever, you know, I root deux len equals mark.length. Mark.length, and let max val equals 2. That's the one that kind of lets us limit that it doesn't go over 9. But for now, we'll just make it 2. So mark len is max length, right? So now I is 2 at this point. So if I is greater or equals max len, then actually, no, we don't want to increment at this point, right? So let's start with the actual first digit that we want. So we don't actually increment the digits. So we're going down, 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 down until we get to here, right? So it's 1, 1, 1, 1, 1, 1, undefined. So now I is greater than length. Now mark I plus plus, right? So now, so wait, we hit the last one. Then we go back 1. So I minus minus So minus minus I. Where do we end up? 1, 2 with I being 2. So I was 0, I was 1, I was 2, I is back to 1. Okay. And we kind of want to do this every time as well. Right? So now 1, 1, 1, 1, 1, 2. Now eventually we get over max val. Let's set it to 3. Like if we do this again, what happens? So it should now just be counting up on the last guy. Okay. Now if mark I is greater or equal max val. So now we've hit the end of the line. And then we'll do a min val. Min val equals 1. So then mark I equals min val. And we back up on the I. So we can do a minus minus here. That should set us back by 1. So if I do this now, 1, 2, 1, 3. All right. So the thing is, we've reset this one to min val, and we've backed up. The thing is, the increment doesn't happen at that point. So we need to increment the previous one. So we hit back to here. Okay, so I'm just trying to think what's the first thing we need to do, because now it's stepping first. And it shouldn't be stepping first. It should increment first. I think that's why we wanted to increment first. Let's go back to that. So if we start on zeros after all, then we can afford to do an increment first before we move on to the next one, right? So let's start here again. So we started element 0. So if I increment this one, right? So this is our starting position. After the first step, we've incremented and we've added to this one. Okay, we do it again. All right. So now here we've reached our length limiter. So we don't want to increment here. We want to reset. We just keep counting up. Then we step back. So then we just finish off 1, 2, 3, 4, 5, 6, 7, 8, 9 instead of stepping. So, okay, so the stepping only happens if we haven't reached length yet. Okay, so we do it the other way around. So we just increment separately. Then, if we are smaller than length, we increment, right? And now 0, 1, 1, 0, 1, 1, and then eventually we hit the last guy, right? So obviously we cannot increment here. So the third one fails because we've incremented I. If I is smaller than length, increment it. So now if I is greater or equal to length, is if I is smaller than length minus 1, I think is basically our modification here. Yeah, so that'll keep incrementing. And now if we do another round of these, we'll end up exceeding our max value eventually. Boom. All right, so, and this is where we exceeded our max value. So we don't want to get there. So here, if mark I, and we want to do this before we're incrementing here, if mark I is greater or equal to max val, or the other way around, I'm just trying to think if we should, if there's an action we should always do, or if we should always check first. It doesn't matter. It's one or the other, right? Off by 1 errors and all that. Mark I is greater than max value. All right, I probably need a break. My brain is, oh my god, it's almost 4. Yeah, I think I need a break. Mark I is greater than maximum value. So now we're going to reset mark I equals minval, right? And I minus minus. And then else do this. So 0, 1, 0, 1, 1, 2, 1, 1. Where did we hit the 1, 1 then? And 2, 1. All right, I'm gonna wrap this into a little function, and then I'm just gonna call it like a bunch of times, right? So we're gonna do a step function. That's just gonna do these 3 things, right? So, and we're gonna do it explicit, and then we can simplify it afterwards. So let's pre-check. So we'll start on them off as with min value, right? So if mark I is smaller than max val, right? Mark I plus plus. So we increment it. That's it, right? Step 1. If I smaller than length, if length is in this case 2, if I is 1, length minus 1, I plus plus. And then we'll just output all this afterwards, right? So we're just going to call step a couple of times, like that. What happens? So it increments the first one. So it does the pre-increment here. So for that to work, we'll have to start one below. So 0, 0, 1, 0, 1, 1, 1, 2, 1, 3, 1, 3. Now, eventually we'll be stuck because we're not doing the increment anymore. So if... So this always happens, right? So we can do an I++ here. And then when we are exceeding our target length, so we're stepping forward, stepping forward, stepping forward. If I is greater or equal to length, I minus minus. So that just undoes that last increment, and we'll get stuck on that last thing forever, right? We're going up one, we're backing down by 1, right? Now, finally, we're checking for max val. So if mark I is greater or equal max val, right? Then we need to do 2 things. We need to mark I, we need to reset it, right? And we're subtracting 1 from I. Now, this won't properly work, right? Yeah, so that one back incremented the first one again, and 0, 0, 1, 1, 0, right. Now, greater or equal to max val. They're not actually greater or equal to max val. 0, 0. Because it got reset before it got output. Okay. So if we go here, 0, 1, 0. So 0, 0, 1, 0, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3. Okay, so that'll do the trick, but it has that oddity at the beginning. So if we don't increment first, but do the check for size first, right? So if I do we want to pre-increment or post-increment? That's the question, right? Well, let's see. If we keep doing this. 1, 2, 3, 1, 2, 3, 3, 1, 3, 2, 3, 3. How do we know we've hit our end? Because here it keeps resetting, right? So basically at this point, because we don't, like, how do we know all of them haven't been, you know, done yet, sort of thing? Because it keeps stepping back. And there should be a sort of final marker that marches on with as we're reaching 9s from the front backwards. And by 9s, I mean the max value, right? So let's extend this. Okay, let's change it to start value of that. And now we want to step forward without incrementing, right? So basically, step 1 is advance. So if I is smaller than length I++, right? So, and I'm gonna make it a little, it's gotta work on a short one as well, right? I++, that's not plus. So I1, 0, 1, 2, 2, 2, 2, 2. Okay, it's stuck on a 2, right? We're advancing. Then we only increment. The thing is, if we only increment when we can't advance, we're only incrementing the end. And then we're backing up, and then we're incrementing the previous one. Okay. So if I is smaller than length I++, else mark I++. So we're only incrementing the last one at the end here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So now, then we output. If mark I is greater or equal to max val, right? Then this should be reset to min val, right? And I needs to be backed up. So 1, 1, 1, 1, 1, 2, 1, 3, 1, 1, 1, 2, 1, 3, 1, 1. Yeah. Except it doesn't increment there. So now we want to increment here. So 1, 1, 1, 2. So why does, oh yeah, because we have the first one here. Let's exclude that one, right? So 1, 1, 1, 2, 1, 3. 2, 1, 2, 2, 2, 3. 3, 1, 3, 2, 3, 3. 4, 1, 4, 2, 4, 3. So at this point, I'm trying to think. If we're hitting the max value here, on this, yeah, so we're incrementing in two different places, right? Here and here, which isn't good, which is why the pre-increment worked well. All right, so let's go back to the pre-increment. I think that'll simplify the logic. So ideally, I want to have only a single place where we're incrementing, right? So we want to increment. So we're starting from the left. We're incrementing and advancing. And now we have to basically clean up our mess, right? So we have to, well, we increment. I'm just trying to think, when do we do this backstepping? So we increment and we advance. If we do those two things here, we increment, advance. 1, 1, blah. Right. Now, if I is greater than length, we'll step back. 1, 1, 1, 2, 1, 3, 1, 4. Okay. We step back. Great for us. Now, if mark I is greater than max val, we want to step back again. We also want to step back here. And this one is going to be equals min val. One, 1, 2, 1, 3, 1. Yeah, so if mark I is smaller than max val, it's greater or equals to max val. So 1, 0, 1, 1. So the problem is this 1, 0. We should never see this one. 1, 1, 1, 2, 1, 1, 2, 1. Yeah, that's the step from going from 1, 1, 1, 0 to 1, 1. If I start on 1 here, our first increment will screw us, right? So we don't want to increment first. We want to advance first. All right, I'm kind of I feel like I'm contradicting myself, right? So let's advance. All right, eventually we'll step through the whole thing, right? So if I is greater than length, we want to increment. If I is greater or equal to length, we're subtracting from I, and then we'll stay on 1 and mark minus minus I plus plus, then we increment mark. But that means we're only increment, yeah, okay, right now. But then when we're stepping back, we're also going to increment. So we're going 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Okay. So now, when we're exceeding max val, we will back up 1 and reset the current one to minimum. So 1, 1, 1, 2. But we also want to increment the previous one, like that. And eventually, we'll get a 1, 1, 1, 2, 2, 1, 2, 2, 1 twice. Why do we get a 2, 1 twice? 1, 2, then we're at 0. We're going back to 1 because we haven't hit the end yet. So, all right. So this is not, yeah, exactly. So that's the problem, right? I want per round 1 increment and 1 addition to our list. And that's why the pre-increment matters, right? Because in this case, we'll have like dead cycles where we're not incrementing. Unless we move this into here, where we're doing the actual increment, right? No, but we're doing an increment here as well. I'm trying to think, is there a time when we'll not increment? Like when we have to step back multiple. No, because we're filling in from the right to the left. So we're always incrementing. Okay. So it makes sense to start at 0. Right. I hope I'm not going in circles here, right? Let's start very simply. We'll do an increment every round. Excuse me. And my chinos is back. And then we'll step through and we'll deal with the consequence of that. So we're incrementing on the front. Now, obviously, we don't want to keep incrementing on the first one. So every increment has to be accompanied by an advance. All right, so we've been here before. So I'm going to try to be careful not to go in circles here. Right. So now, if I is greater than or equal to length, I minus minus. So 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, and so on. Now, what happens when we hit this one? That we're, because if we step back, increment, we kind of have to do this again, right? So since we're stepping forward, so basically, when we're hitting this, and we know we're stepping forward, we actually need to step back twice. 1, 2. So if we just step to here, it'll just come back to here. Right. So if mark I is greater than max val, so I minus equals 2. We step back twice, and what happens? 0, 1, 0, 1, 1, 1, 2, 1, 3. Maxwell is 3. Now we're jumping back to -1. We're hitting 0. And this one, yeah, this is fine. 1, 3 is fine. Mark plus plus I. Okay. So we have to do the same thing with the I here. So this will be a plus plus I. So we have a sort of a pre-position that we can step into, right? So mark 0, mark 1. And mark I. If I is greater or equal to length, I minus minus. It's greater than length. Actually, this won't be necessary anymore because I is exactly where we are at. So 0, 1. If mark I, if I is greater than length, I minus minus. I is greater than length. If I greater or equals to length. So we're hitting here. Wait a second. Let's get rid of this for a sec. What happens? Step 1, we're fine. Step 2, we're fine. Now, step 3, we're incrementing I. So I is 1. Length is 2. So if I is greater or equal length minus 1. Or can we do it at the beginning? Maybe. Maybe. I'd like to do it on the tail end though, if I can. So 1, 0, 1, 1, 1, 2, 1, 3, 2, 3, 2, 4. So this worked, but we had to reset. We got to reset mark I first, right? And then we kind of want to read it out at this point here. So 1 0 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 1 3 1 2 3 3 1 equals minval. Minval is actually, yes, oops, we actually want to do restart over at 0. So 1 0 1 1 1 2 1 3 2 0 2 1 2 2 2 3 3 0. So there's always that 0 that we, but the 0 implies basically that we're only looking at, you know, that gives us the shorter version, right? 3 0. Why does 3 0 not increment correctly? So we're here, 3 0. After this, right, mark I is greater or equal to max val. Ah, because it doesn't proceed beyond that. Once it hits max val on a digit, it... Okay, so we need to hit the length first. So if I get rid of this here for a sec. Right. So yada yada yada. 1 4. So if we do this here before we're printing it out. If length is greater than that. Mark I is 0. If I is greater or equal to length minus 1. There's it's an off by 1 error basically. Maybe a third digit will make it a little bit easier to understand. So we're going 1, yeah. So this tells us this is the shortened sequence that doesn't include these 2 digits. Then 1 1 1 0 1 1 3 4. Right. So once we hit our max val, we need to reset it to 0 and go back by 2. And we got to do that. This only applies. So actually hitting the maximum value. Ah, wait a second. Okay, hitting the maximum value only actually happens on the last cell. Other than that, yeah, okay, we never have to step. Okay, so we don't actually have a max value limitation. We have a last cell limitations, right? So this happens first. And then this happens. And this will not happen without that. So if I do this in here, like this. So we're going down 0 1 3 4. So if so we've incremented I. One sec. So after the first increment, we're in this situation. I is 0. Then I is 1, then I is 2. Then eventually I is 3. So here, else, I minus minus, we do the 1 step back. So 1 1 1 1 2 1 2 1 3. Now the 3 becomes a 0, and we increment there. And we are hitting this on that step. So which of these two is the more relevant version? 1, 1, 1, 1, 1, 1, 1, 2. Okay, so I think it's this one before the reset, right? 3, 1, 2, 0, 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 3, 0, etc. Okay. Or let I equals 0, I smaller than 20, I plus plus step. We're just gonna go through 20 steps. I think I might be overriding I here. Or J. J. So what we got here? We're getting down to the 133 here. 133. Okay, so we have the double step back here, which seems to be causing it problems. So then the question would be, should we do it before our step up? The problem is, so there's if we're only stepping once each turn, right? The problem is, there comes a time, for example, here, where we do have to step twice. We have to step and then we have to step again, right? So it might make sense to decide, do we step forward or back? And then if we're stepping forward, we're outputting, otherwise we're not. And then we don't have to do all this magic stuff either, I think. So let's look at it from a neutral position. I think we still want to do that though, because that gives us the option to include shorter strings as well. So the first check is if our current value is greater than the maximum value. No. Yes. That's when we step back by 1. So if our current value is greater or equal to max value, we don't step forward at that point, right? Because it means we're in a situation like that and we have to step back again, right? So we're doing an I minus minus and a return. That's it, right? So now we're in a position where we know that we haven't exceeded the value yet. So we can increment and we can move forward. And that takes us to where? Because now there should be a place we should here set it to 0. So 1, 2, 3, 0, 1, 3, 1, 1, 0, 1, 1, 1, 1, 1, 1, 1, 1, 2, 3, 0. Wait, 1, 2, 3, 3. Wait a second. 1, 2, 3. So then we're hitting this. So we're just going to do hold the log, step back. Right? So we're going down. We haven't stepped back yet, even though we had a 3 here. That wasn't a step back scenario. So then here we have another step back. But the second step back we're going back here, 3. It should have reset this to 0 and then step back. So this actually needs to step back 2 because it steps forward again in the next round. So we do a step back, and that's increments it by 2. 2, 1, 0, 2, 1, 1, 2, 1, 2, 2, 1, 3, 2, 2, 2, 0, 2, 2, 1, 2, 2, 2, 2, 2, 3. Okay. That looks pretty good actually. So step back, 2, 3, 0, 3, 0, 0, 3, 0, 0. So we step back from here. We increment this to 3. But now 1, 0. Now we should have been stepping forward. What if this is just an I minus minus here? 0, 3, 4. So if mark I maybe we should all the checks up here. So we're hitting here. 0, 1, 2. Mark I greater than equal to. So we do a mark here and a mark there. Before and after stepping. So we got a. Before stepping, it's all zeros, right? No, 1, 0, 1, 0, 0. 1, 0, 1, 1, 1, 1, 1, 1, 2, 1, 1, 3. So after stepping, it's now 1, 1, 1, 4. And then before stepping, we're at 1, 1, 1, 4, but we're looking at 1. So we're kind of looking at the wrong thing here. So what if we only stepped if we needed to, right? So what if we incremented? No, one second. So we're hitting here. The problem is we're looking at the wrong marking, right? The problem is we're getting to here. We've incremented it, but then the next round here, which is this line, we're now looking at mark 1, which is this one. But then we're actually incrementing the next one. So that doesn't make any freaking sense, right? So we need to increment the one that we're looking at here. First of all. Now, obviously, we're not incrementing properly now. And we need to start at 0. Right. So we're starting at 0, 1, 0, 2, 0, 2, yeah. So if mark is greater than max, mark I is greater than max value, we step back. Else, we step forward. So now we can start back at -1, right? So 0, 1, 2, 3, 3. So mark 2. Now this one no longer applies, I think. Right? 1, 1, 1, 1, 1. Okay. So if I is greater than length this, we'll step back 1. So yada, 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 yada. 4. Now, mark I is greater than max value. 0, 1, 2. So after this one, it clearly is greater than max value. So let's check both of these out. Okay, I think that what happens is we're stepping back and then we're looking at the next one. So we might have to change the order. False, 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 false. So now we're hitting true false. So I is greater or equals to length -1. Okay. So 0, 0, 0, 1. True false. I minus minus else I plus plus. If I is greater or equal to length, do this. If mark I is greater than step back. Boom. Now step forward. Can we now just always step forward again? So 0, 0, 1, 1, 1. So we're hitting here. Mark 2. So after this, yeah, because it's incrementing Mark 3, right? So we're hitting Mark 3 here. What if we do this first? What happens then? We're hitting 1, 1, 1, 3. Then we're going back 2, 2, 0, 2, 1, 2, 2, 2, 3, step back 3, 0, yada, 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 3, 3, 3, 3, step back. But we're only hitting, step back, we're only hitting 3, 0 here. Ah, no, now we're getting 2, 0. 1, 0, 0, 2, 0, 0. 2, 0, 0, 0. 2, 1, 1, 1. 2, 3, 1. Okay, I think the second mark here is now the one that's not correct. So 1, 1, 1, 3, 1, 1, 3, 1, 1, 0. Yeah, where's the rest? Why do we get 2 of these? We're stepping back. And then we're returning. Ah, my brain. My poor little brain. My poor little brain. All of you are probably asleep by now. All right, let's just think about this. One last time, and then I'll take a break. So we're starting all at minus, 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 right? We increment by 1. The first thing we need to check is, have we exceeded the length? This doesn't look like a good idea, right? Because we're just going back, we're just staying on the same spot, which is like not really helpful. Actually, no, that's exactly what we want, right? We're hitting the end, stay. Then have we hit our limit yet? If we're hitting our limit, we're resetting the current position, and we're stepping back twice. I don't think that's what we wanted, right? Well, we kind of do, because otherwise we're always incrementing, right? So we have to step back twice. All right, and then we're exiting. We're not hitting our marking here, because we haven't incremented anything yet. So there's no point marking. Right, so this definitely has to be where we do our readout. Three. 1, 2, 0, 1, 2, 1, 1, 2, 2, 1, 2, 3, 1, 3, 0, 1, 3, 1, 1, 2, 1, 3, 3, 2, 0, 0, 2, 1, 1, 0, 2, 1, 1, 2, 1, 2, 2, 1, 3. Actually, that looks good, right? And then if we keep going, eventually we hit 3, 3, 3. And what does it do then? 3, 3, 3, and then eventually it just bleh, right? So, and how do we mark hitting max? Yeah, so that's our kind of eye. Which no, that's not the eye. We're just kind of iterating, right? So how do we find out this one? Coming from the front. So basically, we have a variable called let max equals 0. So when we're doing the step back, I mark I maxed. So every time we're doing a step back, we're checking if we're stepping back I is 2. So eventually we're stepping back to 0. Boom. And we're hitting wait, no, stepping back. to 0. Step back, step back, step back. So that's our exit clause. We're hitting -1 again. So step back, 0, 3, 0. And then here, after the increment, console.log I. I think that I will actually hit something crazy, right? -2, I think. All right. So, if I was -2, return true. And then we can just do while not step. And hopefully it won't go in an infinite loop instantly. Okay. And that should give us all the combinations in a nice linear fashion, including the zeros to imply how far we have reached into the thing yet. And now the question is, can we mix that with our constraints? Right? Does this work for 2 now as well, or does that blow up? 1, 0, 1, 1, 1, 1, 3, 3. Okay. Does it work for larger maximum values? Seems to work. Does it work for smaller maximum values? I think it can't go below 1. 1, 0, 1, 1. Yeah. Minimum value I don't think is used. All right. Let's go on 3, 0. Now, how do we modify the current size and the current sum? We can either calculate it just from the numbers in that array, or we can keep track of it as we run through the array, right? But for now, let's just say mark.reduce cur cur ac plus cur, comma 0. That should give us the sum. 1, 2, 3, 4, 5, 3, 4, 5, 6, yada, 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 all the way up to 3, 3, 3, 9. Now, I'm just realizing we're getting all the duplicates again. How did we avoid them before? I feel like I've just done the wrong thing. We're going through all the iterations. But in reality, we don't want to come all the way back to the first digit again. So we're starting on the first digit. We're going over. So we are skipping this digit. So we're starting out. So every step over, our starting digit is the digits, the highest digit that we're up to on the previous round. So we don't set it to 0. This should get set to this plus 1, right? So we're getting to 113, then this. We're not even going to look. So this should be 1, 2, 3. And then this, 1, 3, this could never be a 3. So instead of setting it to 0, it'll be mark I minus 1 plus 1. What does that look like? 1, 2, 3, 1, 2, 2. So it's actually plus 2. 1 0 0 1 1 1 1 0 1 1 2 1 1 3 1 2 3 1 3 4 1 2 2 3 4 5 2 3 5 3 4 5. If plus 2 is too high, 2 3, so this it worked till here. If plus 2 is too high, 1 2 3, that means it's not possible anymore, right? 1 2 3, you cannot have the 3 in the previous position anymore. Let's make this slightly larger. 1 2 3 1 1 4 1 2 3 1 2 4 1 3 4, and that's the highest we can go. Right? No. Yeah. Does this ever have to be anything else but a 1? I don't think so, right? Because we're doing all the other options with the other ones. Ah, I'm an idiot. This would have been a lot easier. I thought somewhere along the lines my combinations exploded unnecessarily. And basically, the moment this gets larger than our maximum value, we're done. So the moment we're going from 1 3 4 to 1 4 5, we're done. So if mark I is greater or equal to max val, return true. So that should get us. That should get us out earlier. 1 2 3 1 1 4 1 2 3 1 2 4 1 3 4. Okay. If we go up to 9, boom. 1 4 5 1 4 6 1 6 8. No, this is not right. Because there are combinations that haven't any 1 in it. Ah, man. I did it wrong. And I'm gonna have to do it again. Each level. I think it should be the other way around. When we're moving over, we should set this to whatever. We shouldn't start at 0. We should start at 1. So instead of doing this, let me just undo this now. So here we're setting it to 0, right? But instead of doing it on the way back, we should do it on the way forward. So when we're going forward, which we're supposedly doing every round, so instead of doing these shenanigans here, right? So we're starting, and I'm gonna go back to this version because otherwise I'm gonna be nervous. We're doing the opposite of this for a sec. If I is smaller than length, so we're starting, I is -1 0 whatever, we increment it. And the moment we increment I, we're setting mark I to mark I minus 1. Now, of course, that won't work. That won't really work on all these negatives and zeros and all that stuff, right? So we never want to look at 1 0 0. You know, we don't want to look at that at all. So we're starting here. If I is smaller than length. So let's go back to here. So if we don't increment here, yeah. So if so we're incrementing I and setting mark to the previous one. All right, and in fact we can't even start them like this, right? So we're setting that to the previous one. So we have 1 1, 1 1 1, etc. Right. Now, if we're hitting the end of the line, if I smaller than length, else. All right, let's see if we're stopping at the right point. Stop! Right. If I is smaller than length, -1. Boom. 1 1 0 1 1 1. Stop. At this point, I is 2. And the first round here, okay, I is 2. So at stop, we increment mark. Like that. So we're hitting stop. Boom, we're incrementing. We're incrementing. 1, 2, 3, 4. And now, if we're hitting the maximum value, now we do stuff, right? We've hit the maximum value. The problem is, if we're turning around here, we'll never see that version, right? But what we're actually going to do is this. And we'll step back. And that's what happens, right? This is probably a bit chaotic. 3, 1, 1, 0. Okay. So if mark I is greater than maximum value, we don't actually want to reset it, right? Actually, you know what? Yeah, we want to carry the value with us, like that. So if I is smaller than length -1, I plus plus. So at some point, forward. So, forward. Forward, forward. So 1 forward, 2 forward. Stop. Increment, increment, increment. And then revert. So we're hitting the max. We don't want to set it to 0 here. We're just going to step back by 2. So forward, 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 stop. And we want to increment that one. So what happens? 1 1 1 0 1 3 2 2 4. No. So we're stepping back by 1 and increment it. 3 1 1 3 1 2 2. We actually want to set this +1. So, like, we never check 1 1 1, right? So 1 2 3. And then we have a bunch of forwards that don't actually make a lot of sense, right? 1 2 3. Does it ever make sense to go back to doing 2? Yes, it does, right? We want to do 2 3 4, etc. Hey Andy, I think I need a break. My brain is frying. I'm just trying to come up with a simple algorithm to step through all the cage combinations in a linear fashion without recursion. And my brain is a little struggling. So if we start with all zeros, or even all ones, we go over, we increment, we go over, we increment. So we end up with 1 2 3. Like, it does make sense, like, it never makes sense to, so let's say we start like this. And our pointer is pointing at the first element. So what we want to do is copy the element to the next cell. All right, let's do that step by step, right? So we're looking at a cell, first cell. Before we proceed, we copy our value to the next cell, except if we're on the last cell. So let's deal with that first. So if we're on the last cell, if I is greater or equals to length minus 1, right? So we're on the last cell, you know, last marker, whatever. If we're not on the last cell, what we want to do is we want to copy our value to the next cell and step. And let's reverse that, right? If we're smaller than that, we want to copy. So we want to copy, right? And we're going to output that first. So and we're going to do da-da, da-da, da-da. So we're pointing at the first cell. So we want to copy over. So mark I, and we want to make sure we're only doing that, we're not on the last cell. So there's a 1 over. So if so length is 3, if I is smaller than length minus 1, smaller than 2, so it's I is 1, then we're copying over. Except, yeah, 0, 1, or if it's 0, and it starts out as 0, right? So mark I plus 1 equals mark I plus 1, right? So we're starting at the first one, we're copying it over, we're making that a 2. And then there's another marking output here, we don't want that. So then the next round, we are 1, 2, 1. But we're still looking at 0. Okay. We're copying it over, and then we're going I plus plus. So 1, 1, 1, 1, 2, 1, 1, 2, 3. So now we're on the last one. So on the last one, we're checking if we're exceeding the max val. If we're greater or equal to max val, we'll do reverse. Else, we'll do increment. Right? Let's see if it makes the right choice. 1, 1, 1, 2, 1, 1, 3. The last one, reverse. Because our max value is 3. Now, if our max value is 5, we should hit there and it should say increment. Okay, so if we're incrementing, we're doing mark I plus plus. So 1, 2, 1, 1, 2, 3, 1, 2, 4, 1, 2, 5, reverse. Okay. So if we're reversing, first we're going to reset it back to 0, just to let us know, you know, no hard feelings, and we can initialize these all to 0. In fact, if we initialize them as 0 and take zeros from the left, I think that will work better. We'll set that to 0, and then we'll reverse. And the next round, can fly. The next round, we will set, but reverse and increment. Right? So then we go to back 1 and we increment mark there. So 0, 0, 0, 0, 1, 0, 0, 1, 2, 0, 1, 3, 1, 4, 1, 5, reverse and increment, 0, 2, 0, 0, 2, 3, 0, 2, 4, 0, 2, 5, 0, 3, 0. So 0, 0, 0, 0. So this is an empty set, right? Why do we never end up with 0, 0, 1? Copy. Copy. maybe instead of copy, we're just going to step. So we don't do anything here. We just go all the way to the end and start incrementing. 1, 2, 3, 4, 5. Boom. Back 1. Now at this point, reverse increment. At this point, the next one, mark I plus plus, and then equals, actually, equals mark I minus 1 plus 2. Because we need to be 1 higher than what our predecessor is, right? Will be once it gets incremented. So 0, 1, 1, 2, 3, 4, 5, 0, 1, 2. So we're not going to look at 0, 1, 0, for example. And we're not going to look at 0, 1, 1, right? 0, 1, 2. It steps again. So when we're stepping, we're not incrementing. 0, 1, 2, 3, 4, 5, 2, 3, 2, 3, 2, 4, 2, 5, 3, 4, 3, 4, 3, 4. Okay. So here, when we're incrementing, we're going to return. And this, we're going to output only here instead of here. And then we're going to hide all of these. And what do we get? 0, 1, 2, 3, 4, 5, 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. And if I make max volume 3, another 8. Okay, so the problem now is we're incrementing here because we're checking the maximum value only here. So we shouldn't be doing this. Can we do this independently of that? So whenever we're hitting a maximum value, we want to step back. Oh, I feel like we're so close. Which one is our limit? Because the thing is, if we're hitting a maximum value, let's say 0, 4, then the next one will already be higher. 3, 4, 5. So if we're hitting a maximum value first, I'm just trying to figure out which way around we're doing. So if we're hitting a maximum value on the current item is a maximum value. We don't actually want to escape because we want to output it. If it's greater than a maximum value, the stepping forward here is serving us well. And we're filling in from the right to the left. I think that makes more sense. Because it gives us basically the smaller sizes, right? The size of this area is the maximum size, really. I keep thinking that there's a way of avoiding having this area altogether. But I'm not sure if that's true. That's just me lying to myself. Let me think. We're stepping forward. 0, 0, 0. Boom. 1, 1, 2, 3, 4, 5, 6. All we need to know is what the previous number was. We don't need all the previous ones, right? Because they're always smaller. Except we need the previous number on each one. As we're counting up. Let me think. There must be a way of, like, there must be a mathematical way of translating this structure into a linear sequence, right? So the problem is, right, as I get more of these guys, I could be 1, 3, 3, 3, 4. And I don't know if the 1 is a 2 or a 1 in front of the 3, unless I mark it down, right? I mean, I could store it as deltas or whatever, but I guess like the easiest is to just have those numbers. So there's two conditions. I'm hitting the end of the line, I need to back up, or I'm maxing out on my current number. So what's happening here is we're hitting the end of the line, we're backing up, we're doing these shenanigans here. And that's the problem, right? We have two different places where we're incrementing. So instead of doing this down here, if we did all of this here, and here we would just step again. Is that valid? So if we're hitting the maximum value, do we step to the right or to the left? And hitting the maximum value only makes sense here. Mark max val. Well, either one of these lets us increment, right? Or the other way around, when do we increment instead of stepping? When we're hitting the end of the line, that's when we're incrementing. Is that the only, yeah. And when we're stepping back, problem with this is that earlier we had it solved where we knew that we had to keep stepping back, right? I need a break. My brain isn't working properly. But I think we're pretty close. And I'd like to get this algorithm right because it's a simple algorithm. It should be. I've been staring at it for hours. It shouldn't have taken this long, but we'll get through it and then we'll finish this thing. And then we're adding all the other features. I'm glad I started a second function and didn't try to rip apart the other one. Otherwise, I'd be hating myself right now. That's for sure. Well, I think we've gotten pretty far with this. I don't know, like, if I say, okay, can't have 3s, all right, exclude this, must have 1s, must have 1s and 7s, can't have 7s, it seems all pretty good. Now, if this is a plus, this is manually excluded. Yeah, so we have manually and automatically excluded ones. All right. I need some bigger cages for testing as well to see what it looks like. Because this, yeah, 1, 2, 3, 4, like a 9 wide cage, it's not gonna fit. So I think the spacing between these needs to be reduced. In fact, I might have to get rid of the spaces between them altogether. And I think currently I don't wrap digit join. Yeah, I'm currently joining them with white space, which is probably not what we want. Oh. Unexpected token. What? Yeah, wait. Yeah, let's get rid of that space. All right, this guy's banned. All right, so yeah, now they're more compact. Yeah, actually, that's actually good. That should mean we can fit 8 pretty well. It sucks kind of that you have to press them twice to get them back. I'm not sure if I like the three-way clicking here. But it would be the same if I just have a single line of digits to do that. Especially since it changes everything so much. So if we say can't have 3s in them, must have 8 and 9. If I do now 8, 9, 7, 7, 8, 9, 7, 8, 9. Boom, must be a 1. Yeah. All right. Good progress on the visuals here. Actually quite happy with where it's going. Not so good progress on the formula for the min-max and all that stuff. So that's got to wait. I don't know if I'll manage it later today. I mean, this is all in a separate branch. This will not go into the next release. The next release, hopefully I'm going to release tomorrow during my 50th Code Hangout live stream. That'll be tomorrow evening my time. So I'm gonna spitball it and say I'll stream, let's say around Central European time, around 6 o'clock Central European time. So that is Eastern time at noon and Pacific time at 9 a.m. So it's either morning or noon for the Americans and 5 onwards for the Brits. And I'll probably stream maybe good 4 hours or so. 6, 7, 8, 9, 10, yeah. Between 9 and 10 o'clock, something like that. Hope you guys will be able to join. I'm going to do a viewer request stream, so any kind of features you want, let me know, and I'll try to get to them. Any funny ideas, any, oh, I want to play tic-tac-toe or whatever, that's welcome too. And in the meantime, have a good day. Hope you enjoyed hanging out, even though it was just me staring at numbers for most of the time. And I appreciate you joining me. I cannot talk and type at the same time for some reason. Thanks for hanging out, guys. Take